Yeah, hi everyone, welcome back. So we are studying about limit continuity differentiability and then mean value theorem also we see, power series also we have seen. Next topic is applications of derivatives. Okay, so this topic we are going to see, but before that there is a very important prerequisite. When we started calculus, the very first video was this 7 hours of video, right? So here a lot of concept we have covered, like a lot of concept of limit also we covered here, a lot of concepts of application of derivative also we have covered. I would say 70% of the concept is covered here only. Are you able to understand this point? So now there might be some guys who will be thinking that, sir, I don't understand this topic, so let's get started from this video. No, you need to watch this prerequisite video, then only you should come here. You can avoid limit continuity differentiability if you are comfortable with the limit continuity and differentiability. You can avoid that, but you cannot avoid this prerequisite video. Okay, you will surely learn a lot of new things here, so please do watch it. Understandable? All good. After that only we will get started with the topic application of derivatives. And if you are studying right from the beginning, then there is no issue. So this is a very important prerequisite. Understandable? Let's get started now. Directly, sir, you are starting with the question. Where is the concept? The concept is given here. Okay. So these kind of questions we have seen. It's just that fx graph is given. You need to draw the graph and you need to tell me the maximum value of fx in the interval 0 to 2. So how will you do it? Sir, I will draw the graph. Do you know how to draw the graph? Yes, sir. First you differentiate the function. Sir, when I am differentiating, what is the differentiation I will get, sir? 4x minus 2. Right? So, sir, where will be the 0? 0 will come out to be when this function becomes 0. When this f dash x would become 0, sir, it will become 0 at 1 by 2. So, after 1 by 2, the slope will be positive, and before 1 by 2, the slope will be negative. Basically, the breakpoint, or you can say the 0 is at 1 by 2. So, if x is greater than 1 by 2, then the slope will be positive, and if x is less than 1 by 2, then the slope will be negative. That means, sir, the graph will fall down and then increase. That's it. And we can find out the value f of 1 by 2. What will be the value of f of 1 by 2? Sir, f of 1 by 2 will be nothing but 2 divided by 4 minus 1 plus 6. So, what is the answer we are getting? 5.5. And f of 0 also we always try to write down these values as well. So, f of 0 will be nothing but 6. Understandable? Okay. So, if we draw the graph, then this is how the graph will go. Always we will find out the points where the slope is becoming 0. Okay, we will find out the values where the slope is becoming 0, and we will find out the value at x equals to 0 as well, so that we can draw the graph in a good manner. So, let's draw the graph in a good manner. So, this is how our graph will look like. F of x versus x, right? And we need to draw the graph. So, at x equals to 1 by 2, you will get the minimum point, and this is how the graph will be rising. So, this will be the nature of the graph. This will be the nature of the graph. At x equals to 1 by 2, you will get the value to be 5.5. So, at x equals to 0, the value is 6. At x equals to 1 by 2, the value is 5.5. The value is 11 by 2. What they are asking, find out the maximum value of fx in the interval 0 to 2. So, from 0 to 2, where will be 2? 2 will be somewhere here, no? 2 will be somewhere here. So, what is the value of function at x equals to 2? Basically, in this range, from 0 to 2, in this range, what is the maximum value of fx? Sir, I know the value here. The value is 6. I know the value here. So, the value is 11 by 2. What will be the value at x equals to 2? So, always find out the value at boundary points as well. So, what is the value at x equals to 2? Sir, the value at x equals to 2 will be 2 into 2, 4, 8 minus 4 plus 6. What is the value you are getting? 10. Did we do the calculation in a good manner? 4 and 8. 8 minus 4 will be 4, 10. So, at 2 we are getting the value to be 10. So, between 0 to 2, f of 0 was 6. This was 10. This was 5.5. So, this was the minimum value. This was the minimum value. And this was the maximum value. Is that understandable to you or not? So, always draw the graph, see the nature. You would get to know that, sir, at 1 by 2, at x equals to 1 by 2, we are actually getting the minimum value. And, sir, maximum value in the interval 0 to 2, the value is coming out to be 10. If they ask the interval for 0 to 4, then the maximum value will be coming out at 4. If they have asked from 0 to 6, then maximum value will be coming out at 6. Right? What if they would have asked from minus 3 to 2? Let's just say given interval was from minus 3 to 2. So, what you would have done? Minus 3 to 2. Now, here will be your minus 3, no? Minus 3 will be somewhere here. Now, sir, what is the value at minus 3 that we don't know? What is the value at minus 3? So I will find out the values at boundary points as well. Sir, this is the nature of the graph, but let me know the value at the boundary point. I will find out the value at boundary point. At x equals to 2, sir, the value is 10. At x equals to minus 3, sir, what is the value? That I don't know. So what I will do is that I will find out the value of f of minus 3. Sir, what that value will be? 3 into 3 will be 9, 9 into 2, 18. 18 and then you will put minus 3 here. This will become 6. Right? 18 plus 6 plus 6. Value will come out to be 30. Right? If you put a minus 3 here, so what that will be? 3 square will be 9, 9 into 2, 18, here plus 6 and plus 6, so value will come out to be 30. So yes, this will be the maximum value if the interval was from, let's just say, minus 1 to 2. If the interval was from minus 1 to 2, so at minus 3 the value came out to be 30. If the interval was from minus 1 to 2, let's just say minus 1 will be somewhere here, minus 1 will be somewhere here, minus 1 will be somewhere here. So at x equals to minus 1, what is the value you will be getting? So what will be f of minus 1? So always we need to consider the boundary points as well. So minus 1, what value you will be getting? 2. At minus 1 you will be getting the value 2, and then here also 2, and then 6. What is the value you are getting? 10. And what was the value of f of 2? F of 2 was also 10, no? F of 2 was also 10. So in the diagram it might feel like that, sir, this value will be lesser, but they are actually equal. They are actually equal. In the diagram it might feel like that, sir, at x equals to 2 you will get the higher value, but they are actually equal. Are you able to see this point? They are equal. These values are equal. Although in the diagram, because diagram is rough diagram we are making, no? This is not a fair diagram, rough diagram we are making. We got to know that f of minus 1 is equals to f of 2. So what will be the maximum value you will be getting? That will be 10. Is that clear to you? So always the boundary points and those points where the slope is becoming 0, those are our matter of concern, and f of 0 will also be my matter of concern, which is a very easy thing to find out, because if you put x equals to 0 here, very easily you will be able to find out the value. Okay, so did you understand what all points are our matter of concern? Yes, sir, boundary points will surely be the matter of concern if the interval is given. Is that clear to you? Let's try solving the next question. This is a good question. Find out the maximum value of fx, which is x square dot e to the power minus x. So at what point of x the maximum value will occur for the given interval, which is from minus 1 to 2. So for this given interval, at what value of x you will get the maximum value of fx e to the power minus x. First of all, you let me know e to the power anything, this will always be positive. Always remember this thing. What I am saying, exponential to the power anything will always be positive. No matter whether here positive value is there, negative value is there, it will be always positive only. Why is that so? What is the graph of e to the power x? This is the graph of e to the power x. And what is the graph of e to the power minus x? This is the graph of e to the power minus x. These graphs we have seen. So isn't the value always positive? It is always in the positive hand side, no? The value of x could be anything. Value of x could be anything, but always you are getting y to be positive. Always you are getting y to be positive. So e to the power anything will always be positive. Always, always, always remember that. Say yes or no. Yes, sir, I will always remember it. Okay then. Now here, what we need to do? We need to find out the maximum minimum value. We need to comment on the graphs. That means what I need to do? First step is differentiation. So first as it is differentiation of second plus second as it is differentiation of first. Is that clear to you? X square e to the power minus x, then e to the power minus x, then 2x. Then e to the power minus x is coming common. This 2x I am writing down first, and then x square minus x square. Right? So next what will come common? X e to the power minus x, and then 2 minus x square. So this will become what we are doing. First as it is e to the power minus x, then plus e to the power minus x, then 2x. E to the power minus x is coming common, minus x square plus 2x. Then x is coming common. Now this will be 2 minus x. Understandable? Okay. Now where will be the poles? Poles you can say, or zeros you can say. So where you will get this function to be 0? What all are the points? Can this ever be 0? Basically what I am saying is that x into e to the power minus x into 2 minus x, I am equating it to 0. So from here what you will get? Sir, x could be equals to 0. Or you can get, sir, 2 minus x could be equals to 0. That means x equals to 2. And next one, e to the power minus x is equals to 0. So this will take x equals to infinity. So infinity and minus infinity we never consider. So I told you one thing, that this will be always greater than 0. This will be always positive. But at x equals to infinity, this will become 0. So we don't need to consider. Only two zeros we are having, which is 0 and 2. Now think about it. If your x is greater than 2, then your slope will be positive or negative. This is 2 minus x, not x minus 2. If you need to write down x minus 2, then this is how you will write down x minus 2. And you want this to be greater than 0. Basically, this is what you want. If you want this particular thing, you want this to be 0, greater than 0, then there is this minus sign, no? So what this will make? Less than 0, right? So if x is greater than 2, then what will happen? If x is greater than 2, just see this scenario or see this scenario. If x is greater than 2, then slope will be negative, right? Let's just say x equals to 3. Then here you will get minus 1. Here you will get 3, right? And here you will get e to the power minus 3. This is positive, so this will be negative. And since the power is even, here also the power is even, here also the power is even, so sign will be changing. So plus minus, this will be the scenario. That means first slope will decrease, then it will increase. Okay, till this point it will increase. What will be the scenario is that first there will be a decreasing slope. Now if you feel like that, sir, I am not understanding anything, that means you did not see the prerequisite. Okay, you need to see the prerequisite, then only you will be able to understand what we are doing here. Okay, so prerequisite is very important. So decreasing and then increasing and then decreasing. Now if it is decreasing, where it will end? Basically, if I draw the graph now, so what I will do, first of all I will find out these values. F of 0, what is the value of f of 0? Sir, if you put 0 here, 0 square e to the power minus 0, e to the power minus 0 is 1, 0 into 1 is nothing but 0 only. And what is the value of f of 2? Sir, f of 2 is nothing but 4 e to the power minus 2. So sir, if I draw the graph, I got to know one thing, that this is how, sir, my graph would look like. The fx graph would look somewhat like this. Sir, 2 points I have got, f of 0 and f of 2, these were my matter of concern. And sir, if I draw the graph, what I can see is that before 0 the graph will be increasing. So this is how the graph would be coming, right? Sorry, graph will be decreasing, and then, sir, the graph will increase, then the graph will increase, and then, sir, graph will decrease again. So this will be the scenario. Okay, and what was this point? At f of 2 the value was 4 e to the power minus 2, 4 e to the power minus 2. So 4 e to the power minus 2. So this is, so this 4 e to the power minus 2, sir, at x equals to 2, what I am getting? 4 e to the power minus 2. And now what is the value of 4 e to the power minus 2? Just in numerical number we can find out. So what will be the value of 4 e to the power minus 2? That we need to find out. So 2e square, that is 0.541. Okay, this value is nothing but 0.541. So this is the nature of the graph. But now the question is that, sir, you are saying that yes, the graph will go down, but the graph can go down like this as well, and the graph can go down like this as well. So how it will go down? That we need to check. Someone would say that, sir, at infinity it can go to minus infinity, no? And someone can say that, sir, it can go to 0 as well, or someone can say that, sir, it can go somewhat like this. Basically, it cannot increase, decrease. Someone can say that, sir, it will end up some, the infinite value could be 1 as well. Basically, you know one thing, the graph will decrease. You know one thing, the graph will decrease. Till what point it will decrease? At what point it will decrease, that you don't know. What does that mean? I need to find out the value at infinity. What I am supposed to find out? I am supposed to find out the value of fx if x is tending to infinity. So if x tends to infinity, then what is the value of fx you are getting? This is what I am supposed to find out. Although for solving this question it is not required, because in this question we only need to care about the values between minus 1 to 2. So this is x equals to minus 1. Between minus 1 to 2 only we need to take care. That's it. This is our matter of concern. But still, if I want to draw the graph, how will I draw the graph? That I am telling you. But in this question, you only need to care about between minus 1 to 2. So between minus 1 to 2, only in this much span I need to care about that what will be the value. Are you able to understand this point? But still, if we are finding out, then what I can see, sir, if I directly put the limit infinite e to the power minus infinity, sir, it is becoming infinite into 0 form, which is an indeterminate form. So what I would do is that I would infinite by infinite form I will make. So this is how I will make the form. So x square divided by e to the power x. Then what I would do is that I will differentiate 2x e to the power x, infinite by infinite form. Then again I will differentiate, sir. I will get 2 e to the power x, and then, sir, I will directly put the limit 2 divided by infinity. So value is coming out to be 0. That means at infinity the value will be actually 0. So this is how the graph will look like. Now looking at the graph, I might feel that, sir, the maximum value will occur at x equals to 2. So sir, answer will be x equals to 2. Option will be mentioned. Option will be mentioned as x equals to minus 1, x equals to 0, x equals to 1, x equals to 2. You will see that, sir, at x equals to 2, sir, maximum value we are getting, differentiation maximum value we are getting, and we will click on it. I told you one thing, if interval is given, always check at the interval, check at minus 1 as well. At x equals to minus 1, what is the scenario? What will be the value you will be getting? This is a rough graph, no? How do you know that at x equals to minus 1 I will get the lesser value or higher value? Let's try getting with the value at x equals to minus 1. What is the graph? X square multiply with e to the power minus x. E to the power minus x. X square e to the power minus x. So what value you are getting? E to the power 1. And what is that? roughly around 2.7. So at x equals to minus 1, this will be x equals to minus 1. X equals to minus 1 will be somewhere here. Again I am saying, no, it is a rough graph. X equals to minus 1 will be somewhere here, and the value you will be getting is, someone would say that, sir, this gap is very less, so this gap is very high. So rough graph it is, no, it is a rough graph. You are not making a fair graph. So at x equals to minus 1, the value you are getting is, at x equals to minus 1, the value you are getting is roughly around 2.7. So at what point of x the maximum value is occurring? At what point of x equals to minus 1. This will be your answer. Are you able to understand this point? So a lot of people would mess up these kind of questions. Just they will understand this is maxima, this is minima, sir, here the slope is becoming 0. No, if the interval is given, no. So always first thing is that we will draw the graph and then we will see the nature. Is that clear to you? Okay, drawing this graph I would get to know that, yeah, I need to care about the least possible value, and in between the values will be lesser only. So then I go to know that at minus 1 you are getting the higher value. Are you able to understand this point? Okay, well and good. So what will be the answer? Answer will be x equals to minus 1 will be the answer, and this is how the graph would go. Okay, so fx graph also we have drawn. So all kind of graph we can draw, but I hope you are enjoying the concept. I hope you are actually learning the depth of the concept. So what concept will say here also, we will draw the graph, but again check at the boundary points as well, because we know the nature, but what we need to find out, we need to find out the maximum or minimum value. Understandable? So let's go to the next question. Try doing it on your own. Find the maximum and minimum value of fx. Can you comment on fx? I told you e to the power anything is always positive. It is always positive. This value is always positive. This value is always positive. This value is also always positive. What does that mean? That means the complete graph will always be positive. Is that clear to you? The graph will be always positive. That's for sure. But sir, what will be the nature of the graph? So let's find out the nature. So for finding out the nature, what we need to do? We need to differentiate. So you can differentiate in any manner, but what clicked to me was the given function was given like this. Differentiation is up to you. You can differentiate in any manner, but what I can think here is that, can I do something like this? Say yes or no. Plus 1 and minus 1. Now if I separate it out, I can separate out in this manner. And this will get cancelled out. What is the answer I am getting? So this is your fx we are getting. Now differentiation would become easy, no? So just by looking at this expression, I can directly write down this expression in the examination. Okay, just here I will see, and directly I will write down this expression if I am having good enough practice. So what will be the differentiation now? So differentiation will be nothing but differentiation of 1 will be 0. Differentiation of minus 1 by fx will be 1 upon 1 plus e to the power x square. Then differentiation of 1 plus e to the power x will be nothing but e to the power x. So this is the differentiation we are getting. Now what do you see here? Isn't it always positive? So e to the power x is always positive. This is positive. This is positive. Then there is whole square always positive. What you are understanding from here? That f dash x is always greater than 0. F dash x is always greater than 0. This is what we have understood. Right? So the slope is also always positive. What does that mean? Slope is always positive. What does that mean? The graph will be always increasing. The graph is always increasing. Slope positive means always increasing. What is the meaning of positive negative slope? The graph will decrease and then increase, right? This is what we used to do. Positive, negative, positive. What we used to do? The graph will increase, then decrease, then increase. But now this time there is no 0 here. Always you are getting positive only. That means graph will always keep on increasing. The graph will keep on increasing. Okay, so the graph will keep on increasing. So when I go to know that, yes, it is always increasing, or other name are monotonically increasing. What is the other name? Other name is monotonically increasing. Monotonically increasing. Like it is having only one nature, which is always increasing. So monotonically increasing. Or what is the other name? Strictly increasing. Okay, strictly increasing. This is the other name. So these are the names it is having. Anything could be written in the examination. So the graph is always increasing. So when the graph is always increasing, can I find out the value at minus infinity and plus infinity? What I mean to say is that I know one thing, that fx will be always positive as well, and it will be always increasing. Always increasing. Always increase. Right? So it can increase in this manner. Right? It can increase somewhat like this. It can start from here. Right? or someone would say that sir it can increase in this manner. So what is the value at minus infinity and plus infinity? I will find out the value. So here value I would know, here also value I would know, then I would know that it will always increase. That's it, right? So what I would do is that I would find out the value at plus infinity and minus infinity. So limit x tending to minus infinity f of x. So limit x tending to minus infinity e to the power x divided by 1 plus e to the power x. What is the answer you will be getting? E to the power minus infinity. Simply you just need to put down the value. The value will come out to be e to the power minus infinity upon 1 plus e to the power minus infinity divided by, answer is 0, and limit x tending to infinity e to the power x 1 plus e to the power x. So what this will become? Is it an infinite by infinite form? Yes, you might feel that sir it will become infinite by infinite form if it is tending to infinity. So what will happen? 1 plus e to the power infinity. So sir, what you will see here is that sir it is becoming infinite by infinite form, because e to the power infinity is also infinity, this is also infinity. But if I am smart enough, what I would see that sir e to the power x will become very larger. No, it is becoming infinite by infinite form. You can apply L'Hopital. You will get the limit to be 1. You will get the answer to be 1 if I apply the L'Hopital rule. L'Hopital rule I can apply. Upper side you differentiate, downward side you differentiate. This will become e to the power x, this will also become e to the power x. E to the power x and e to the power x will get cancelled out. What is the answer? You will be getting 1. Or what I can think, sir, at infinity this e to the power x will become much larger than 1. So what I can do? I can ignore the 1. So e to the power x and e to the power x will get cancelled out. Answer will be 1 only. So we have done enough practice on limits, and I hope you will be able to find out the limit in a much quicker manner. So ideally in the examination, what I will see, if I need to draw the graph of fx, no. So ideally in the examination, what I would see is that, okay, this is the value, always it will be positive. When I find out the slope, it is also coming out to be positive. That means it will be always increasing. If I put minus infinity here, it is becoming 0. If I put infinity, this value is very large, this value is very large, both will cancel out, answer will be 1. So starting from 0 till 1 it will go. That's it. So starting from 0 at minus infinity, the value is starting from 0 and till 1 it will go. Starting from 0, always increasing till 1 it will go. So this will be the nature of the graph. That's it. So this value will be 1. At x equals to 0, what will be the value? E to the power 0 will be 1. 1 plus 1, the value will become 1 by 2. At x equals to 0, the value will become 1 by 2. Okay, and this is minus infinity, this is plus infinity. So at x equals to 0, the value will become 1 by 2. And then at infinity, the value will become 1. At infinity, the value will become 1. So this is how the graph will go, always increasing. So what is the maximum value? Fx maximum. So maximum value this graph can attain is, that is nothing but 1. Sorry, not 1 by 2. The maximum value this graph can attain is 1. And what is the minimum value it is attaining? Minimum value it is attaining is, the minimum value it will attain is, that is 0. From 0 to 1. 0 to 1. Is that clear to you? Okay, understandable. So answer is 1, 0. Maximum value is 1, minimum value is 0. So this is how we can solve these kind of problems. Very simple, very straightforward. Just differentiate and your job would be done. Try drawing the graph. If you have drawn the graph, job would be done. Understandable? Let's understand a new topic. We will solve more problems, don't worry. Okay, this was just your understanding of prerequisite. Like if someone would have directly jumped to this video without even watching this video, if someone is directly jumping on application of derivative, then he would understand that yes, I need to watch this video, otherwise I will not understand anything. So here most of the concepts are covered. So this was like a revision of this particular video, that so that you can understand these concepts that we have already studied, and we need to check the values at boundary points. So in this interval, what is the maximum value, what is the minimum value, all these things you will be able to understand. So that's why I picked these questions, so that you revise whatever that you have already studied. Understandable? Let's understand the domain of a function. What do you mean by a domain? So first you draw the graph. Can you draw the graph of fx? Yes sir. Fx, which is under root x, we used to draw the graph in this manner. We used to draw the graph in this manner. Say yes or no. Do you remember this graph? This is how we used to draw the graph. Do we used to draw the graph in this manner? Did we draw the graph in this manner? No. The value was not 0 here. The value was undefined. What I used to say is that if you are drawing mode under root of x, then you would say that x has to be greater than 0, greater than or equals to 0. Say yes or no. Basically, the graph is drawn only for x greater than or equals to 0 only. For x less than 0, the graph itself is not even drawn. Is that understandable to you or not? So this is known as domain of the function. that for x less than 0, the graph is not even defined. Basically, if you design a system which is doing the job of under root x, basically if you apply 1, the answer is given under root 1. If you apply 2, answer is given as under root 2. If you apply 3, answer is given as under root 3. So when you design this particular block, no, in this block you will put up a note and you will write down that one thing, that if you are applying some input, make sure that input is greater than or equals to 0. On this chip, whatever the chip or whatever the block that you have designed, on this block you will put a stamp. On that stamp you will write down that x has to be greater than equals to 0. So domain of function is always defined. Either the user will define, okay, either the examiner would define, or you need to define on your own. The examiner who is setting up the question paper, he may define it on his own. If he is not defining, then you need to define on your own. You need to define it on your own. So x is greater than or equals to 0. This is the domain of this function. Okay. What about 1 by x? Sir, have we drawn the graph of 1 by x? Yes, sir. We have drawn the graph of 1 by x. So the graph was somewhat like this. If you don't remember it, then it's your problem. Okay. I am not going to explain the graph. If x is 1, the value is 1, x is 2, the value is 2, x is 3, the value is, in that manner it will keep on going. And here the nature was like this. If x is 0 minus, the value was minus infinity. If x is minus 2, the value will be minus 1 by 2, then minus 1 by 3, in that manner. So this was the graph. I told you one thing here. What was the value of f of 0? That was undefined. Someone would say that, sir, the value of f of 0 is infinity. The value of f of 0 is infinity. Someone would say that, sir, 1 by 0 is infinity. If you are saying this thing, that means you did not watch this prerequisite video. Okay, 1 by 0 is not infinity, 1 by 0 is undefined. So 1 by 0 is undefined. So if you design this particular block, what you will write down on the stamp paper? You will write down one thing, that don't apply x equals to 0. X should not be equals to 0. Otherwise, what he will say? Otherwise, the output will say undefined. You apply anything else, 2 you apply, output will be 1 by 2. Minus 2 you apply, output will be minus 1 by 2. 3 you apply, output will be 1 by 3. Whatever you apply, no issue. But if you apply x equals to 0, then there is a problem. So what you will say? The domain of this function is, that all the real numbers you can apply, but you cannot apply 0. This is the domain. Okay, all the real numbers you can apply, but you cannot apply 0. Real minus 0. This is the domain. What about ln x? Sir, we have drawn the graph. Basically, what is the meaning of domain? The meaning of domain is that whatever the input you can apply, that's it. So we have drawn the graph. I told you one thing. What did I tell you? That inside ln there can never be a negative value. Why there can never be a negative value? What is the meaning of ln? Ln means, let us say, log base e minus 1. How much power of e should be there such that you get minus 1? E will always give you positive power. Right? I always told you one thing, that e to the power x will always be positive. So what should be the value of x such that you get e to the power x equals to minus 1? Never it is possible, no? Right? Are you able to understand this point? Right? So inside inside ln, you will always put the positive value, and you cannot even put 0 as well. You cannot even put 0 as well. So what does that mean? That x has to be greater than 0. What is the value of ln 0? That is also undefined, no? Someone would say that, sir, ln 0 is minus infinity. Then again you are having some problem. Ln 0 plus is minus infinity. Ln 0 plus is minus infinity. What I mean to say is that log e to the power 0. What should be the power of x such that, what should be the power of e such that you get value 0? The power of e should be minus infinity, or you can say negative very high. Negative very high. Right? But it is for 0 plus. Like nearly exact 0 they are asking. Exact 0. What is the graph of e to the power x? The graph of e to the power x is like this. You say that at minus infinity the value will go to 0. But we can never say, no, the value is exact 0. Exact 0 we can never get. Can we reach to minus infinity? No. We can never reach to minus infinity. So can we get the exact value 0? No. We say that yes, sir, x equals to minus infinity, or we say that x is tending to minus infinity. When you reach at minus infinity, then you will get the value to be 0, but you will never reach there. So x should be greater than 0. Always take care of this thing. Should be greater than 0, not greater than or equals to 0. So I will write down one more thing, that it is not greater than or equals to 0. This is wrong. Greater than 0. Whatever that is there inside the ln, it should be greater than 0, not greater than equals to 0. Is that clear to you? Here what was the scenario? Greater than equals to 0. Under root x greater than equals to 0, because under root 0 is also defined, that is equals to 0 only. but ln 0 is undefined. Is that clear? So here greater than equals to 0, but for ln case it is greater than 0, and here it was x cannot be equals to 0. What about this? Think about it. Sir, I don't know the graph of 1 by ln x. Okay, it is fine. But here what is the function given? The function given is ln x. What does that mean? That means, sir, inside ln, whatever that is written, that should be greater than 0. This is the first condition. This is the first condition we have got. First condition we have got. But there would be one more condition. What is that? What if ln x is equals to 0? If ln x equals to 0, then what will happen? Y will become 1 by 0, then it will become undefined. Say yes or no. That means ln x should not be 0. Ln x should not be 0. What is the meaning of ln x should not be 0? This ln goes inside, this will become e to the power 0. What does that mean? Ln x should not be equals to 1. What does that mean? All the values greater than 0 will be accepted, but x cannot be equals to 1. Or how you can write down? X can go from 0 to infinity, but 1 is not accepted. This will be the domain. 0 to infinity, 0 is not included, right? X has to be greater than 0, not greater than equals to 0. So 0 is not included, infinity will never be included, because you can never reach infinity, and then 1 is also not possible. Why 1 is also not possible? Because, sir, when this becomes 0, then there is a problem, right? So denominator should never be 0. Till this point, what you have understood? If there is under root, if under root fx is written, what does that mean? Fx should be greater than equals to 0. If 1 by fx is written, then what that would be? Fx should not be equals to 0. And if ln fx is written, then what it would be? Fx has to be greater than 0. That's it. If you just remember these things, then your job is done. What if I write down 1 by ln under root or 1 by fx? This scenario I write down. So let's try this. Okay, what I am writing down? Next page. Let me add a page, and I am asking you question. Domain we need to find out for y equals to 1 by under root ln x square minus 2x. Find out the domain. What you will say? First of all, denominator should not be equal to 0. This is the first condition. The denominator, this denominator should not be equals to 0. Should not be equals to 0. So what is under root fx should not be equals to 0? That means this should not be equals to 0. That means ln x square minus 2x should not be equals to 0. What does that mean? That means x square minus 2x should not be equals to 1. Right? And at what point they will become 1? So they should not be equals to 1, or you can say that x square minus 2x minus 1 should not be equals to 0. Okay, so what all are the roots we are getting? That is minus b plus minus under root b square. Basically, when this value will become 0, what I mean to say is that when this particular value will become 0, when x square minus 2x minus 1 is equals to 0, at what point they will become 0? What I wanted to do is that they should not be equals to, this particular thing should not be equals to 0. If this particular thing should not be equals to 0, that means this particular thing should not be equals to 1. Because what is ln 1? ln 1 is 0. So this particular thing should not be equals to 1. That means x square minus 2x should not be equals to 1. If I take 1 this side, that means x square minus 2x minus 1 should not be equals to 0. So when they will become 0? When your x is minus b plus minus under root b square minus 4ac upon 2a. Say yes or no? Right? So when your x is 1 plus minus, this is 8 and this is 4, 1 plus minus under root 2. So when your x is 1 plus under root 2 and 1 minus under root 2, then there is a problem. That means x should not be equals to 1 plus under root 2 and 1 minus under root 2. This is the first condition we have got. So this is some rough work we have done. Understandable? So what was the first condition? That this should not be equals to 0, this should not be equals to 1. So there, if this is becoming 1, what does that mean? X square minus 2x minus 1 should not be equals to 0. So when this will be 0, when x is equals to minus b plus minus under root b square minus 4ac. So what is the condition we are getting? 1 plus minus under root 2. Okay, so x should not be equals to 1 plus under root 2, x should not be equals to 1 minus under root 2. This is the first condition we have got. What is the second condition? That if the function is defined, then whatever that is written inside the under root, whatever that is written, that should be greater than or equals to 0. That means ln x square minus 2x should be greater than or equals to 0. Is that understandable to you? Whatever that is written inside, that should be greater than or equals to 0. This is the second condition for under root. This was the condition for 1 by fx. This was the condition for 1 by fx. Now this is the condition I am putting for under root fx. This is the condition I am putting for under root fx. So what we are doing? X square minus 2x minus 1 should be, basically what we have done is that x square minus 2x, now this ln goes this side, this will become e to the power 0, that will become 1. So x square minus 2x minus 1 should be greater than or equals to 0. Now this is the condition we are getting. What we are getting is that we will have to add pages. The condition that we have got now, that x square minus 2x minus 1 should be greater than 1. So it should be greater than 0. This is the condition we are getting, that x square minus 2x minus 1 should be greater than or equals to 0. That means we are having some function gx. This should be greater than or equals to 0. That means I need to draw the graph of this gx. I will have to draw this, right? So for drawing this, what I will do? 2x minus 2. So at x 2x minus 2, then it could be written as 2 into x minus 1. What does that mean? If I draw the number line here, that for x greater than 1, the slope will be positive. For x less than 1, the slope will be negative. That means the graph will follow this nature. So what is the value of g of 1? G of 1 is nothing but 1 minus 2 minus 1. So what is the answer you are getting? Minus 2. Right? Here if you put 1, the value you are getting is minus 2. So let's check the graph. So this value is 1. And where the graph was becoming 0, x square minus 2x minus 1 was becoming 0 at 1 plus under root 2 and 1 minus under root 2. What is the value of 1 minus under root 2? That will be 0.4041. So here the graph was becoming 0 and here also the graph will be becoming 0. So the graph will look somewhat like this. This is how the graph will look. So can anyone tell what will be these points? At 1 the value was minus 2. This value is minus 2. What will be these points? Can anyone tell? Yes sir, when the graph is becoming 0. And have we find out those points? Yes sir, absolutely we have find out. Those points are nothing but 1 plus under root 2 and 1 minus under root 2. So this point is nothing but 1 plus under root 2 and this point is nothing but 1 minus under root 2. 1 minus under root 2. Say yes or no. Right? Now what is our condition is that our graph should be greater than or equals to 0. Greater than or equals to 0. That means these values I can expect. These value will be accepted. But here in this range, the graph is negative. What I mean to say is that if your x is between minus 1 by 2, 1 minus under root 2 to 1 plus under root 2, in this range, or you can take the equality sign as well. In this range, your gx is less than or equals to 0. And if you ignore the equality sign, so this is the scenario. But what do I want? I want the value to be greater than or equals to 0. Right? That means these values I should avoid. So condition we are getting is that it could be anything, x could be anything, but not the value between 1 minus under root 2 to 1 plus under root 2. This is the condition 2 we have got. Condition 2. This is the condition 2 we have got. Is that clear to you? So this is the condition 2 you are getting. What I should do, shall I keep it in the box? Condition 2. Okay, and condition 1 also we got. This was your condition 1. Condition 1. Condition 1 we have got, condition 2 we have got. Now let's check out the other condition. What is left? ln is left. What ln will say? Whatever that is written inside me, that should be greater than 0. So ln will say that whatever that is written inside me, condition 3. What ln will say? That whatever that is written inside me, that should be greater than 0. Not greater than equals to 0, greater than 0. So x square minus 2x should be greater than 0. Who is saying that? ln is saying that. ln fx is saying that. That whatever that is written inside me, that should be greater than 0, otherwise I will not be happy, right? That means x square minus 2x should be greater than 0. So this is the rough work we have done. Now again I will have to draw the graph of x square minus 2x, or I don't need to draw the graph. What I can see is that x into x minus 2 should be greater than 0. I can take x common, no? So what I am saying is that x into x minus 2 should be greater than 0. So at 0 we are getting one of the root, and here also we are getting one of the root, plus minus plus. So when your x into x minus 2 would be greater than 0 in this condition, but it is not greater than or equals to 0. This is the inequality we are solving. X into x minus 2 inequality we are solving. So in this condition I will expect, but greater than 0, no? So these values will not be included. That means you can take all the values, but not the values between 0 to 2. Not the values between 0 to 2. This is the condition 3 you are getting. Condition 3 you are getting. So from all these three conditions, what is the answer you are getting? Values to avoid. Values to avoid. First guy is saying that x should not be equals to 1 plus under root 2 and 1 minus under root 2. 1 plus under root 2 and 1 minus under root 2. And let's make a number line as well. What is 1 plus under root 2? Let's write down the approximate value. 1 plus under root 2 is 2.41. Okay, it is nothing but 2.41. So 1 plus under root 2 would be somewhere here. 1 plus under root 2 would be somewhere here. Right? This is the first guy is saying. What is the second guy is saying? He is saying that x should not be between 1 minus under root 2 to 1 plus under root 2. Where will be 1 minus under root 2? 1 minus under root 2. What will be the value of 1 minus under root 2? It will be minus 40. So this is 1 minus under root 2. So he is saying that avoid all the values between these 2 points. This should be avoided. Avoid all these values. Avoid all these values. Right? And who is the what third guy is saying? He is saying that avoid all the values between 0 to 2, including 0 and 2. Including 0 and 2. So where will be 0? So 0 will be somewhere here, and where will be 2? 2 will be somewhere here. So he is saying that all these values should not be accepted. Last guy is saying that all these values should not be accepted. He is saying that all these values should not be accepted. And the upper guy is saying that these boundaries values should also not be accepted. That means whatever that is written inside, that should not be accepted. That means apart from them, everything would be accepted. Is that understandable to you? That 0 is here, 2 is here, 1 plus under root 2 is here, 1 minus under root 2 is here. That means whatever the value that is written inside, they should not be accepted. After that, everything should be accepted. Here, whatever that is written, that should be accepted. And here, whatever that is written, that should be accepted. And these boundaries values should also not be accepted. Is that understandable to you or not? That means what will be the domain? Domain will be x belonging to all the real values will be accepted, but not the values between 1 minus under root 2 and 1 plus under root 2. Along with that, this 1 minus under root 2 and 1 plus under root 2 will also not be accepted. That means boundaries values will also not be accepted. This is the domain. Is that understandable to you or not? So can you find out the domain of any function now? So this is the last question that is required to solve. Everything we have solved here. 1 by under root ln x square minus 2x. So first of all, denominator should not be equals to 0. Denominator should not be equals to 0. This is the condition we have got, job done. Second, whatever that is written inside the under root, that should be greater than or equals to 0. Then this is the condition we have got. Now looking at these two conditions only, I got to know that 1 plus under root 2 will not be accepted, 1 minus under root 2 will not be accepted, and whatever the value that is there inside, that will also not be accepted. And how did we solve it? We assumed that this is a separate function. This should be always greater than 0. Let's draw the graph. I understood that here the graph is going down. That means these values of x should not be accepted. So these values of x are not accepted. 1 minus under root 2 to 1 plus under root 2. These are not accepted. Right? And after that, what we saw, that whatever that is inside the ln, they should be greater than 0. So here I thought that let's draw the graph, but drawing the graph is not necessary. What I saw here, it is becoming a simple inequality. You could have drawn the graph as well. No, x square minus 2x. Can you draw the graph? X square minus 2x. This is your fx. Can you draw the graph? Yes, sir. I will do the differentiation. It will become 2x minus 2. So it is becoming 0 at x equals to 1. So positive here, negative here. The graph will decrease and increase. So what is the value of f of 1? The value of f of 1 is nothing but minus 1. And where the graph will become 0? When this becomes 0 at x equals to 0 and 2. So this will be 0. This is 2 and this is 1. So here it is becoming 0. this kind of graph I will be getting, sir. This is the graph I will be getting. At f of 1, the value is -1. This is the graph I will be getting. That means in this range, no values will be accepted. That means between 0 to 2, no values will be accepted. But boundary points also I will not accept. Why is that so? Because the condition is it should be greater than 0, not greater than equals to 0. That means x equals to this particular value being equals to 0, that is also not accepted. So I can draw the graph in this manner. Very easily you can draw the graph on your own, and you would understand that these values will not be accepted. Right? So 3 condition we got, and then I took the intersection of them. He is saying 0 to 2 I will not accept. All the values between 0 to 2 I will not accept. He is saying that all the values between these 2 points I will not accept, and he is saying that I will not accept the boundary points as well. So this is the answer we are getting. Is that clear to you? So this is the meaning of domain. Directly in the examination they can ask you the questions of domain that find out the domain of this particular function. Understandable? Now next questions are easy only. Y equals to x square. Let me know the domain. Y equals to x square. What will be the domain? Sir, all the values of x, right? No problem, no. X square is not having any problem. X square is not having any problem. No matter whatever the value you put, I am always fine. So whatever the real values you want to put, I am always fine with that. So what is the domain? X belongs to real number. That's the domain. Whatever the value you put, I am absolutely fine with that. What will be the domain here? Again, check out the conditions. What all are the condition is there? Denominator should not be equals to 0. Condition 1. This ln x square minus 5x plus 6 should not be equals to 0. That means x square minus 5x plus 6 should not be equals to 1. Whatever that is inside, if this becomes 1, then it will become 0. 1 by 0 will be undefined, so it should not be equals to 1. So x square minus 5x plus 5 should not be equals to 0. So I will find out that when they will become 0. So when they will become 0. So they will become 0 for plus minus under root b square minus 4ac upon 2a. Okay, b square is 25 minus 4ac, 4 into 5 will be 20. So this is the condition. That means x should not be equals to plus 5 plus under root 5 divided by 2 and 5 minus under root 5 divided by 2. This is the condition that we have got. This is the condition 1 we have got. Okay. Second one, what is that? Whatever that is written inside, that should be greater than 0. Whatever that is written inside, that should be greater than 0. So shall I need to draw the graph? Do I need to draw the graph? Someone would think that yes sir, I will draw the graph 2x minus 5 at 5 by 2 plus after that slope will be positive, then negative, then the graph would go like this. Then I will find out the value at 5 by 2 and then I will draw the graph at x equals to 0, the value is 6 and this will be my 5 by 2. I don't know whatever the value I will be getting. In that manner my job would be done. But again, what I can sense here, what I can sense, nothing I can sense. I will have to draw the graph only. No, I will not have to draw the graph. What I will do, x square minus 3x minus 2x plus 6 should be greater than 0. Say yes or no. Now what you can do, x into x minus 3 into 2 into x minus 3. So it has become x minus 2 into x minus 3. So this has become a simple inequality, no? Right? So without drawing the graph as well we can do now. This has become a very simple inequality. So this is x equals to 2 and this is x equals to 3. So if it is greater than 3, then positive and then negative. So it should be greater. That means these values should be accepted. All the values, these values will be accepted. That means they are saying that x greater than 3 will be accepted and x less than 2 will be accepted. So these values will be accepted. Or you can say that all the values except the values between 2 to 3. And along with that, boundary points also will not be accepted. Why they will not be accepted? Because the value has to be greater than 0, not greater than equals to 0. Because whatever that is written inside, that has to be, whatever that is written inside the ln, that has to be greater than 0. So what all are the values to avoid? Values to avoid. Sir, values to avoid are the value between 2 to 3 and x should not be equals to 5 plus minus under root by 2. 5 plus minus under root 5 divided by 2. 5 minus under root 5 divided by 2. So let's draw them on number line. What is the value of 5 plus under root 5 divided by 2? Plus 5. This is nothing but 3.61. And what is this? Under root 5 minus 5 divided by 2. This is 1.38. Again, let me do the calculation. .38. So value is 3.61 and 1.38. So minimum value is 1.38. Then the value is 2. Then the value is 3. Then the value is 3.61. So what they are saying, that whatever the value is there inside, that should be avoided. That means 2 to 3 should be avoided. This should be avoided, and these values should also be 1.38. And so basically what all should be accepted, that I am writing down. This, every value less than this, basically all these values will be accepted, but 1.38 will not be accepted. 1.38 will not be accepted, and all the values between 2 and 3 will not be accepted, and even 2 will not be accepted. Is that clear? This is the domain. This is the domain. Is that clear or not? Think on your own. No, all the values between 2 and 3 will not be accepted, along with the boundary points. 2 will also not be accepted, 3 will also not be accepted. Along with that, this 1.38 and 3.61 will also not be accepted. Rest all the values will be accepted. This is the domain. Is that clear? How we can write down? Domain will be x belongs to real number, where you are not accepting two values which are these values, and you are not accepting this domain as well, which is 2 minus 3. This is how we can write down. Okay, this is how we can write down. Is that clear? All the real values except these two guys, except this range. Is that clear? This is the domain. So directly they can ask these questions, what is the domain of this function? These kind of questions are asked in calculus. Okay, and why we are studying the domain? Because of the problem solving. We will require some problem solving. That's why we are understanding the domain. Okay, so this is like a prerequisite that we have done. We have understood the meaning of a domain. Is that clear to you? So some 30 minutes we have spent here. We have understood the meaning of domain. I hope for every function you can find out the domain now. Now let's solve the inequalities. Sir, we have already studied it. Why you are doing it again? For the sake of revision. But you studied only for the numerator case. What if there is numerator by denominator? So we will see these cases as well. But yeah, let's get started with this one. So have we solved these kind of questions? Yes, sir. First of all, we will find out where are the zeros. Zeros you can call it, where are the roots you can call it, or where are the poles you can call it, whatever you want to call it. So sir, this is the scenario. So let's draw them on number line. Number line I will draw -7, -4, -1, 3 and 5. So if the value is greater than 5, then positive. Now we will see the power. Here you are having even power. Even power will not change. Then odd power, then even power again, and then odd power. So at even power the sign will not change. So here also positive, then negative, then positive, again sign will not change, positive and then negative. Right? Less than 0 we need. Less than equals to 0 we need. That means this will be accepted. So these we have already seen. Okay, that's why I have moved fast here, and these will be accepted. Less than or equals to equal sign is there. That means these boundary points will also be accepted. That's it. Okay, so this is the inequality. This is the inequality of function we have drawn. How we draw it, that is completely understandable to you. Sir, first of all, write down the zeros of this function. So zeros you can call it, or roots you can call it. From now onwards we will call it root. So roots of the function is -7, -4, -1, 3 and 5. Then you saw the even power. Even power is there at 5. Even power is there at -4 as well. At even power the sign will not change. If the function is greater than 5, then plus, right? Because everything will be positive here. So here the function will throw positive value. This will also throw positive value. This will throw negative, then positive, and then negative. Why the sign is not changing? Because even power was there. What we need to take, value should be less than 0. That means we need to take the values between -1 to 3. That means here x will belong to -infinity to -7. -7 will be included. Union -1 to 3. That's it. Understandable? So this will be the range of x. This will be the answer of this inequality. Okay. Sir, what if numerator by denominator is there? First of all, when you see this function, one thing you will directly say that x cannot be equal to 0. That's it. First of all, denominator should never be equal to 0, otherwise there is no meaning of this function. Basically they are saying that find out fx greater than or equals to 0. First of all, the very first thing I will say, x cannot be equal to 0, denominator should not be equal to 0. This is the very first thing I will say. Why is that so? Because if denominator is equal to 0, then your job is gone, right? Everything is gone, function will become undefined. So x cannot be equal to 0. This is the first condition I will write down. Understandable? Now you want this function to be greater than 0. Think about it. If you want to be greater than 0, let's just say a by b is there. I want it to be greater than 0. Forget about equality sign we will take care. I want it to be greater than 0. What does that mean? A has to be positive and b has to be positive. A has to be negative and b has to be negative. Because negative will get cancelled out, this will become positive. And if this is the scenario, positive by negative, then you are gone, or negative by positive, then you are gone. They will be less than 0, right? So from here, what is the condition you are getting? That sir, x minus 3 should be greater than 0 and x should be greater than 0. This is the one condition you are getting. That means from here what you are saying that x should be greater than 3 and x should be greater than 0. So from collectively you are saying that x should be greater than 3. This is what you are saying. Or if both are negative, then also your job would be done. If both are negative, then also your job would be done. That means x should be less than 3 and x should be less than 0. So collectively, one guy is saying that should be less than 3, one guy is saying that should be less than 0. So collectively, this is the condition you are getting. That means you are saying that, sir, 0, x less than 0, x greater than 3, both will be accepted. Now, first of all, let's talk about the boundary points now. X cannot be equal to 0. This is the first condition we have wrote, no? X cannot be equal to 0. Forget about anything else. X cannot be equal to 0. Now, secondly, since it is greater than equal to 0, if I put x equals to 3 here, what I will get? 3 minus 3 is 0. 0 divided by x. If I am putting x equals to 3, so this will be 0 divided by 3. That is equal to 0 only, and greater than equal sign is also there, no? So I will accept this one. That's it. Is that understandable to you? Is that clear to you? That how did I get the answer? This is the thinking process. This is the thinking process. I will tell you the method now. Because if the big function is there, no, then you cannot think there. You will have to follow the method there. So what method will say? That you put numerator equals to 0, denominator equals to 0 and find out the roots. What I will do, first task is that you put numerator equals to 0 and put a denominator equals to 0 and find out the roots. So what are roots you are getting? 3 and 0 you are getting. So 0 and 3. Again see what is the power here? Even power, right? Odd power, odd power. Here also there was x equals to 3 we are getting. So this is odd power and this is odd power. So odd power and odd power we are getting. If x is greater than 3, positive sign. Odd power, sign will not change. Odd power, sign will not change. Odd power, sign will not change. So positive, negative, positive. That's it. What we need? Greater than 0. That means what will be accepted? This will be accepted and this will be accepted. Secondly, what I will see? Sir, there is a greater than equals to sign. That means boundary point I will take. This boundary point also I thought, but I would see where the denominator is becoming 0. At x equals to 0, denominator is becoming 0. I will not accept it. There you go. Job done. So similar thing is there. Whatever that we used to do for this kind of things, the same thing we are doing here. Just take care of one thing. What that you need to take care. Where denominator is becoming 0, rest all you don't need to care. Same answer you are getting here as well. We will solve the example. It will be more clear to you. So this was the actual thinking and this is the process. Process is that you put numerator equals to 0, denominator equals to 0. That means you find out all the points where these functions are becoming 0. Once you find out, draw them on number line, plus minus as per even odd power. Do your job done, and then plus minus plus you will do it, and then based on that greater than equals to 0 you will select it. But just make sure one thing, that whenever your denominator is becoming 0, that point we need to avoid. That's it, nothing else. Is that clear or not? Solve this question. First of all, write down all the points where the function is becoming 0. Numerator is becoming 0 at 3 and minus 2, and denominator is becoming 0 at 0 only. Understandable? Draw them on number line. Minus 2, 0, 3. Tell even odd power. This is having odd power. This one is having even power. And this one is having odd power. If x is greater than 3, everything will be positive. Odd power is there, sign change. Even power is there, no sign change. Odd power is there, sign change. What we need to accept? Less than equals to 0. But you know that where my denominator is becoming 0, at x equals to 0, my denominator is becoming 0. That means x equals to 0 is not accepted. Less than equals to 0, they are saying that everything would be accepted in this range. everything would be accepted in this range. But make sure one thing, x equals to 0 will not be accepted. X equals to 0 will not be accepted. Now sir, greater than equal sign is there, that means x equals to 3 will also be accepted, x equals to minus 2 will also be accepted. That's it, job done. That means x belonging to minus 2 comma 3 but not 0. Put up any point and you can check the answer. Put x equals to 2, you check the answer, it will be less than 0 only. Put x equals to minus 1, you check the answer, it will be less than 0 only. Okay, and put x equals to 4, you will get to know that it is greater than 0. So this is how we need to solve. Very simple thing, very simple process. Just whatever that we did here, the same kind of process we need to do here as well. Just make sure one thing, where the denominator is becoming 0, that point we need to avoid. Whenever you see fx by gx, no, always gx equals to 0 is your matter of concern. Whenever your denominator becomes 0, I will be aware the denominator should not be equals to 0. Next question, solve this one. This is the last one, right? After that we will understand maxima and minima. So solve this question. Do it on your own. What you will do? First of all, let me know where the denominator is becoming 0 at x equals to minus 7, 3 and 5. What all are the roots? Let's write down the roots. The roots are minus 9, minus 8, 0, 2, 4, minus 7, 3 and 5. Let's write down in an order. Minus 8, minus 7, minus 9, minus 8, minus 7. Minus sign is completed. Then 2, 3, 4 and 5. So how many roots? 3, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, fine. Okay. And even odd power also we will talk about. Let's get started with minus 9, minus 8, minus 7, 0, 2, 3, 4, 5. Okay. So let's talk about the even odd power. Here the power is even, no sign change. At minus 8 power is odd. Or if the power is odd, we are not going to write down. Here also power is odd. At x equals to 0, the power is even. At x equals to 2, the power is odd. At x equals to 3, the power is even. At x equals to 4, the power is odd. At x equals to 5, the power is odd. So 3 even power are there, 1, 2 and 3. Yes, fine. Okay, so again get started. Plus, minus, plus, plus, minus, minus, plus, minus and minus. Understandable? Again let's check. Plus, then minus, then plus, even power, plus, then sign change, then no sign change, then sign change, no sign change. Okay, job done. Now less than equals to 0 we need to accept. That means all these things will be accepted. All these things will be accepted. And all these things will be accepted. Now first of all I will take care of one thing, that minus 7 should not be accepted. Minus 7 should not be accepted. 3 should not be accepted, already not accepted. And 5 should not be accepted, not accepted. Less than equals to 0, that means rest of the boundary points will be accepted. Rest of the boundary points will be accepted. That means x equals to minus 9 will be accepted, x equals to minus 8 will be accepted, x equals to 0 will be accepted, x equals to 2 will be accepted, x equals to 4 will be accepted. That's it. This is the answer. So what will be the answer? X belonging to minus infinity to minus 8 union minus 7 to union minus 7 is not accepted, no, minus 7 to 2 union 4 to 5. There you go. This is the answer. So this is how we will solve the inequality. A very complex concept we have understood very easily. Okay, so this is how you solve the inequality. Minus infinity to minus 8, minus 7 to 2 and 4 to 5. No wavy curve method, this method, that method, no. Simply our intuition, first we saw that how to understand, how to think, and then we have built up a method. And this is how we can solve it. Although this much complex thing will not be required, but somewhere it might be used. Okay. Next topic is understanding the concept of a maxima and minima. Very simple thing. I have drawn a particular graph. On this graph only I will tell you what is maxima, what is minima, what is local maxima, what is local minima, what is absolute maxima, what is absolute minima. So when we talk about maxima and minima, no, maxima means maximum, minima means minimum. So when we talk about maxima and minima, we talk about all those points where the slope is 0. First of all, this is the condition. Other points also we can talk about, but as of now you understand where the slope is 0, talk about those points. Okay, so where the slope is 0? So the slope is 0 here, 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 and the slope is 0 here. So these are the points where the slope is 0. Now I will go to this point and I will ask him, talk to your nearby guys. What nearby guys will say? Nearby guys will say that, sir, we are lesser than you. That means he is maximum to the nearby guys. I am just talking about the nearby people. He will go, you will go to this one, you will go to -4, you will ask -4 that if you talk to the nearby people, if you talk to this guy, if you talk to this guy, what is the value they are giving you? Lesser than 4. That means he is local maxima. Local maxima. Go to this guy and ask to the nearby guys. Nearby guys. So they are giving you maximum more value, no? At x equals to -2, the value you are getting is 1. But at -2 plus, you are getting somewhat higher value. At -2 minus, you are getting somewhat higher value. Basically, if this is the scenario, that means he is the maxima guy because nearby values are lesser. So this is your local maxima. If this is the scenario. And if this is the scenario, no? That means nearby guys are low. Sorry, nearby guys are higher, right? This value is higher, this value is higher. But here, this value is lower, this value is lower. So this point is local maxima and this point is local minima. Is that clear to you? So he is the boss in his locality. He is the boss in, he is not the boss in his locality. So local maxima, local minima. Is that understandable to you? So what all are the points of local maxima? So local maxima is, sir, -4. This x equals to -4. I am talking about only the x value. So x equals to local maxima. If I talk about local maxima, x equals to, sir, -4. -4. Then you can see this structure. See this structure. You are getting this structure here as well, right? Then x equals to -1. Talk to the nearby guys, okay? Then you go here, you go here, you go here. Again, you see this structure, no? Talk to the nearby guys. Talk to the nearby guys. They are lesser than x equals to 4, right? And what about the local minima? You go here and you ask him x equals to -2. All other guys are higher. Then you go to this person, ask the nearby guys. All the values are higher. And then you go to this point, ask the nearby guys. All the values are higher. This is the condition. Now, what is the meaning of global maxima? Global maxima means absolute maximum. Basically, can you let me know what is the maximum value of fx? Maximum value of fx. What is the maximum value of fx? Sir, maximum value. Maximum value fx is, look here, fx is 0, right? Here the fx is 0. So in this particular range, what is the maximum value of fx is? That is 4. And that is occurring at x equals to -4. And what is the minimum value of fx? Minimum value of fx. Sir, minimum value of fx is nothing but -3, right? This is the minimum possible value. And where it is occurring? It is occurring at x equals to 2. So this is the point of global maxima. And this is the point of global minima. So he is the maximum possible value and he is the least possible value. At what point of x they are occurring? At x equals to -4, at x equals to 2. That means who is your global maxima? X equals to -4. And who is your global minima? X equals to 2. Is that understandable to you? X equals to 2 is the global minima. X equals to -4 is the global maxima. So if I have given this x equals to -4 at separate name, then I will ignore it. Previously, I called it local maxima, but when I saw the complete graph, when I saw the complete locality, I got to know that he is the maximum guy. When I saw the complete locality, I got to know that he is the minimum guy. So here also I will ignore this too, right? So they will become the, this is your local maxima, right? This will not be local maxima, this will become global maxima. What this will become? This will become global maxima. What this will become? This will become global minima. What this will become? This will become local minima. What this will become? This will also become local minima. And what is this? This is also local maxima. Local maxima. Is that understandable to you? So in the examination, if global maxima, local minima, or global minima, if all these words are written, will you be able to tell the meaning of those words? Absolutely. What is the meaning of critical points? So critical points are those points where your slope is 0 or undefined. So there are two kind of words are used: critical points and stationary points. So here we are using the word stationary point. People think that both of them are same, but actually they are not same. But as of now, we are just understanding that what do you mean by stationary points. So all those points where the slope is 0. So what all points are there where the slope is 0? So the slope is 0 at -4, -2, -1, -4, -2, -1, -4, -2, -1, then 2, 4 and 5. 2, 4 and 5. So all those points where the slope is 0, that point is known as stationary points. There is another term that is used, critical point, that is something different. Okay, all the points where slope is 0, where slope is 0. Is that clear to you? So is the concept of this global maxima, local maxima, local minima, local maxima, is that clear? Everything is clear, right? Comment what will be the value of what is the value of x at which local maxima is occurring. So basically you need to tell all the points. If we are talking about global maxima and global minima, so I will say one thing: what is the maximum value of fx? Can you tell what is the maximum value of fx here? So that is nothing but infinity. Graph is going till infinity, and where it is occurring, so dot 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 you are showing, no, that means it is occurring at x equals to infinity. And what is the minimum value of fx? Sir, graph is going towards negative infinity, and where it is occurring, sir, in the negative hand side. So what is your global maxima? Global maxima is at infinity. What is your global minima? That is also at minus infinity. Local maxima, sir, you find out the points where the slope is 0, find out the points where the slope is 0. In the nearby point, this is the condition we are getting, and this is the condition we are getting. What does that mean? So this is the point of local maxima, and this is the point of local minima. So local maxima is occurring at x equals to -2, and local minima is occurring at x equals to, this is 0, so at x equals to 0. That's it. So always when they talk about local maxima, always when they talk about global maxima or global minima, just always think that I need to find out the maximum value of fx. That's it. I need to find out the maximum value of minimum value of fx. So I will get local maxima here and global maxima here and global minima here. But if they talk about the local maxima and local minima, then simply find out the points where the slope is 0. And then see what is the structure you are getting. If this is the structure, then maxima. If this is the structure, then minima. This is for maxima and this is for minima. Understandable? Okay. Solve this question. What is the best possible way? Draw the graph and your job would be done. Can I draw the graph? Sir, what is the function given? Fx equals to x square minus 4 whole square. Can I draw the graph? Yes, sir. Do the differentiation. 2 x square minus 4, then do the differentiation of inside. Do the differentiation of inside, that will become 2x. So this will become 4x, x plus 2, x minus 2, f dash x. So from here value of x we are getting is -2, 0 and 2. -2, 0 and 2. Plus, minus, plus, minus. Graph decreases, then increases, then decreases, then increases, and then decreases. This is the scenario you are getting. So what is the value of f of -2? First find out the value of f of -2. If you put -2 here, the value is coming out to be 0. What is the value of f of 0? F of 0 is nothing but 16, right? If you put 0 here, 16. What is the value of f of 2? F of 2 is also 0. So if I draw the graph, how the graph will look like? This is 0. At -2 you are getting the value to be, this is the scenario, right? So the graph will look somewhat like this. At -2 the value is 0. Then at 4 the value is 16. Then the graph would go down, and then wait a second, what I have done here. Sorry guys, the graph is going down here, then at this point it will rise up, then at this point it will fall down, and then at this point it will rise up. Okay, so this is how it will rise up. One more doubt can you say? That sir, when these kind of functions were there, no? So at that time as well, sir, at that time, sir, you were caring about value at minus infinity and plus infinity. You were carrying a lot. But here you are saying that, sir, it will end up infinity only. It will also end up at infinity only. How you are so comfortable? Because it is polynomial, no? So for polynomial, I don't need to care. Basically, if I find out what will be the value of f of infinity, so that will be infinite, very high value, infinite minus 4, that will be infinite only, it will be infinity only. And what is the value of f of minus infinity? That will also be plus infinity only, because minus infinity square, it will become minus infinity square minus 4 to the power infinity. So minus infinity square will become plus infinity, sorry, to the power 2, sorry guys, to the power 2. This will be plus infinity only. So when it is polynomial, they will go to the maximum value, that means either to plus infinity or minus infinity. But when it is exponential function or ln x, if these kind of functions are there, no, then I need to care about the value at plus infinity and minus infinity. Is that clear? So this is the graph we are getting. So what all are your stationary points? First of all, let me know what all are my stationary points. So all these are my stationary points. Stationary points. Stationary points. Okay. Now what is the maximum value your function fx is attaining? Do I have the page? Yes, sir. What is the maximum value your function is attaining? Sir, maximum value my function is attaining is infinity. And where it is occurring? It is occurring at x equals to plus infinity and minus infinity as well. Plus infinity and minus infinity as well. So I am having 2 points of global maxima. These are the points of global maxima. 2 points we are having, plus infinity and minus infinity. And what is the minimum value your fx is attaining? What is the minimum value? So the minimum value my fx is attaining is 0. That is 0. And at where they are occurring? It is occurring at minus 2 as well and plus 2 as well. That means they are my global minima. Global minima. So sir, these were the stationary points, minus 2, 2 and 0. So you have talked about, sir, you have talked about minus 2 and 2, but sir, 0 is not talked. This particular point. Here what is the slope? Slope is 0. So what is x equals to 0? X equals to 0 is, and what is the structure you are getting? This kind of structure you are getting, no? So nearby points are smaller. What does that mean? X equals to 0 is your local, x equals to 0 is nothing but local maxima. Right? Now someone will ask, sir, global maxima, global minima, local maxima we have talked about. Sir, what about local minima? Local minima. So here local minima are global minima only, no? Because only 2 minima we are having here. Only 2 minima we are having here. This is also minima and this is also minima. See the structure? See the structure. This is also minima and this is also minima. And that is absolute least value as well. That means here your local minima equals to global minima only. Is that clear to you? So whatever the stationary points are there, no, we need to care about all the stationary points we have cared. Is that clear to you or not? So if we are able to draw the graph, no, then job is done. No need to care about anything. If we are able to draw the graph. So surely we are able to draw the graph. Let's go to the next one. Fx is given as e to the power x plus e to the power minus x. Find the local maxima, local minima and all those things. Here I will care about the value at infinity and minus infinity. But before that, if I need to draw the graph, what I will do the differentiation. F dash x I will do. E to the power x and this will become e to the power minus x. This is the f dash x. When your f dash x becomes 0, what is the point where f dash x is becoming 0? So e to the power x minus e to the power minus x should be equals to 0. Then e to the power x should be equals to e to the power minus x. From here I can sense that, sir, x should be equals to minus x. That means x has to be 0. So your stationary point would be nothing but x equals to 0 only. If your x is greater than 0, then slope will be positive. Why is that so? X is greater than 0. Let's put x equals to 1. This value minus this value, it will come out to be positive. And if your x is less than 0, then this will be the scenario. And you can draw the graph as well, no? What is the graph of e to the power x? This is the graph of e to the power x. This is the graph I have drawn for e to the power x. And what is the graph of e to the power minus x? This is the graph of e to the power minus x. This is the graph of e to the power minus x. So who is higher? For x greater than 0, who is higher? E to the power x is higher. So e to the power x is higher than e to the power minus x, that means the value will be positive. And here who is higher? E to the power minus x is higher. So if e to the power minus x for x less than 0, e to the power minus x is higher than e to the power x, that means value will be negative. Right? So how the graph would go? Sir, first decreases and then increases. Now what is the value of f of 0? If I find out f of 0, so f of 0 is nothing but e to the power 0 plus e to the power 0, that is 2. I need to care about the values at plus infinity and minus infinity as well. So if I put f of infinity, or better I should say limit x tending to infinity, so that would be e to the power infinity plus e to the power minus infinity. So this will be infinity plus 0 will be infinity only. And what is the value of f of minus infinity? That would be limit x tending to minus infinity. So e to the power minus infinity plus e to the power infinity, that will be also infinity only. So this is infinity, this is infinity. At x equals to 0, the value is 2. This is the scenario that we are getting. So what kind of graph you will be getting? So this kind of graph I will be getting. At x equals to 0, the value is 2, then infinity to infinity. Do I need to tell what will be the point of local maxima and local minima or anything? Just let me know what will be your global minima. Global minima. Global minima is sir nothing but x equals to 0, because at x equals to 0 you are getting the minimum value. Basically here you are getting at x equals to 0, at x equals to 0 the value you are getting is 2. So global minima is x equals to 0. That is your local minima as well, because only one minima you are getting. So that is your local minima as well. What is your global maxima? Global maxima. So sir, global maxima will be nothing but x equals to minus infinity and plus infinity. That's it. This is the answer. Okay, very simple thing, very straightforward. There is nothing in these kind of problems. Just draw the graph and your job is done. So if you have followed the basic mathematical foundation, then there is no one who can stop you in solving these kind of problems. Otherwise, you will do first derivative test, second derivative test, you will put this value, that value. No mathematics will be involved there. Simply you are doing some calculation and all. No meaning of mathematics would be there. Okay, there are something called first derivative test, second derivative test. Although we will see those tests, but that is not mathematics. That is just a method. This is the mathematics. Draw the graph and understand everything. And every single graph you will be able to draw. You give me every gate PYQ. For every gate PYQ, every graph we can draw. Okay, without doing the needless calculation. Let's understand the difference between stationary points and critical points. So what do you mean by stationary points? Stationary points means all the functions where your slope is 0, all the values of x where your slope is 0, and critical points means all the values of x where your slope is 0 or undefined, or undefined. So where the slope is 0, here the slope is 0, right? Here slope is undefined, here slope is undefined. Sharp turn is there, no? Sharp transition is there. Here slope is undefined. So what all are your stationary points here? What all are your stationary points? Stationary points. Stationary points. So sir, I see only one point where the slope is 0, that is x equals to 1, right? And what all are your critical points? Critical points. Sir, critical points will be where the slope is 0, slope is 0 only at this point, but here the slope is undefined, here the slope is undefined, and here also the slope is undefined. So these are your critical points as well. Okay, this is the meaning. Although both are treated as same, because most of the times what will happen is that we will get only those functions where, like, we will get continuous and differentiable function. In the examination we will get continuous and differentiable function. What kind of function? This kind of function we will get. Isn't it a polynomial? Since it is a polynomial, it will be continuous and differentiable everywhere, right? Continuous and differentiable everywhere. So what does that mean? Critical points and stationary point would be same, because f dash x will never be infinity or minus infinity or undefined. Say yes or no. If you find out f dash of x, what you will be getting? Sir, 3x square divided by 3, then sir 7x plus 10. If you solve this, if you put this equals to 0, for finding out the stationary points, what we will do is that I will put this equals to 0, then what answer I am getting? X equals to minus 5 and minus 2. So these two are your stationary points as well. Along with that, they are your critical points as well. Critical points as well. Critical points as well. And along with that, they are your stationary points also. Why is that so? Because sir, the point is that fx can never be, f dash x can never be undefined. Can never be undefined. Okay, so critical points are same as stationary point here, and most of the times this is the condition we will be getting. But what if for a random function fx, I don't know what is fx, but f dash x is given by this particular expression. This is your expression of f dash x. You need to find out the stationary points and the critical points. So for stationary points, what I will do? For stationary points, what I will do is that I will put f dash x equals to 0. So if I put this equals to 0, what values we are getting? Divided by x square into x minus 7. If I put this equals to 0, then the value of x we are getting is minus 2 and 3. So these are your stationary points. What I am writing down? Stationary points. What about the critical points? So for critical points, sir, what if first condition is that for critical points, sir, two conditions are there. When your f dash x becomes 0, so sir, those points are minus 2, 3. And second condition is when f dash x is undefined. So f dash x is undefined. What does that mean? That means fx is non-differentiable. Right? fx is non-differentiable. Oh, sorry. F dash is undefined. That means fx is non-differentiable, but we don't need to care about it. We just need to care about that when your f dash x will not be defined. When your f dash x will not be defined at x equals to 0 and 7. Although it is not a matter of concern because fx is not even given. F dash x is already given, no? So when it will not be defined at x equals to 0 and at x equals to 7. So what all are your stationary points? Sorry, what all are your critical points? So sir, critical points are minus 2, 0, 3 and 7. These are my critical points. These are my critical points. Now you can say one statement. What is that statement? That all stationary points are surely critical points. All stationary points are surely critical points, but not all critical points are stationary points. Although no one will ask you these kind of statements in the examination hall. These are not very important. It's just that you need to understand what is the stationary points and what is the critical points. In some textbook, if you find out critical points are all those points where your f dash x is 0 and your f dash x is undefined, or you can say fx is non-differentiable. Understandable? Okay. Non-differentiable, along with that, yeah, only non-differentiable. Okay. Those points are your critical points. Understandable? So we will see this new topic now. This is done. Okay. Critical points we have seen. We have seen about stationary points. We have seen maxima, minima. All these points we have seen. Now something new we are going to discuss, which we will see after a break. So some simple questions I am asking you, and after that I will ask you to analyze this particular graph. We will understand something about the slope, but this time we will talk about the nature of the slope. Okay. So very interesting topic it is going to be. Just after a break I will come back and I am asking you these simple questions. You need to answer these simple questions. If with increase in x, if y is decreasing, then what will be the value of dy by dx? These questions you need to tell. Understandable? Okay, so let's take a break and then I will come back. You can also take a break and you revise whatever that we have studied. Yeah, welcome back. So we are going to study about the nature of the slope. We need to comment on the nature of the slope, whether the slope will be increasing, decreasing, slope will be positive, negative. All those things we will comment on. But before that, you will answer some simple questions for me, which you already know. In the basics, we have covered all these points. So if your x is increasing, with the increase in x, if your y is decreasing, then what will be the value of dy by dx? That means x is increasing. What does that mean? If x increases means dx is positive, right? And y decreases, what does that mean? Dy is negative. So what will be the value of dy by dx? Negative by positive will be equals to negative only. Now what they are saying, with the increase in x, if y increases, then what will happen? With the increase in x, that means dx is positive, and y is also increasing, that means dy is also positive. Then what will be the value of dy by dx? So that will be positive by positive will be positive only. Now answer this thing. With the increase in x, dy by dx is increasing. That means slope is increasing. What does that mean? That means dy by dx is positive. So can I write down in this manner? Change in x, that is dx, and change in dy by dx. Can I write down? What is the meaning of change? Change means d. Change in what? Dy by dx. Now can this be written as d by dx of dy by dx? Right? What was this? Dx dy. So can we write down d into d by dx of y? Similarly, d by dx of dy by dx. Yes, right? So isn't it like that double differentiation? There was a y, you differentiated that, what you got? dy by dx. Then you again differentiated it, what you are getting? dy dx multiply with dy by dx. So this is represented by d2y divided by dx square. This is the representation. Is that clear to you? So what is the representation? d2y divided by dx square. So if with the increase in x, that means dx is positive. If your slope increases, that means if dy by dx is positive, then d2y by dx square will also be positive only, no? Say yes or no. This particular thing is positive, this particular thing is also positive. Here dy by dx increases, that means not d by dx, it is dy by dx. Basically, if y increases, then I am saying dy is positive. So if dy by dx increases, then dy by dx will be positive. Is that clear to you? So this particular thing is positive, this particular thing is also positive. Positive by positive will be positive only. And what is the notation? Notation is d2y by dx square. With the increase in x, if your slope is increasing, then your double differentiation will be positive. And with the increase in x, if your slope decreases, if the change in slope is negative, if your slope decreases, then d2y by dx square will be nothing but negative. Do you agree to this point or not? Is this point understandable to you or not? Very, very, very important point, but very, very straightforward as well. With the increase in x, if my slope is increasing, then my d2y by dx2, that means my double differentiation, what this is known as? Double differentiation. Then my double differentiation will be positive. If with the increase in x, if my dy by dx is decreasing, then my double differentiation will be negative. Is that understandable to you or not? Let's get started with the question. Slowly the things will become more comfortable. Don't worry about it. Draw the graph of fx. Fx equals to x cube, sir. This graph I have drawn 10 times. I don't know, sir, why you are wasting my time. I am not wasting your time. Something very fruitful, something very interesting we are going to study. Fx equals to x cube we need to draw. There you go. This is the graph that we will get. Fx equals to x cube. A lot of time we have seen it. Fx equals to x cube. What is the differentiation? F dash x equals to 3x square. The graph is always increasing, no? The graph is always increasing. If the graph is always increasing, what does that mean? F dash x is always positive. What does that mean? Graph is always increasing. Right? If graph always increases, that means slope will always be positive. And you can see from here as well, the slope will be 0 at 0 only. After 0, since it is having an even power, so after 0, you will get positive graph. Here also you will get positive slope. Right? 3x square is always greater than 0. No, it is pretty obvious thing. X square is always greater than 0. So 3x square will always be greater than 0. That means slope is always positive. So graph is increasing. There is no doubt about that. Now let's talk about f double dash x. What will be f double dash x? Sir, f double dash x would be nothing but 6x. When this will become 0? 6x will become 0 at x equals to 0 only. So for x greater than 0, this will be positive. For x less than 0, this will be negative. That means I am talking about f double dash x. What I am talking? I am talking about f double dash x. So what I am saying is that f double dash x is positive. F double dash x is positive for x greater than 0 or equals to 0, you can say. Whatever it is. Let's talk for greater than 0 and less than 0. And it will be negative for x less than 0. Now let's talk about f double dash x more. Okay. Let's talk about f double dash x more. This is the theory that we have seen. But let's talk about it intuitively. Intuitively, I am going to talk about f double dash x. So this is the graph of fx. First, I am drawing the graph of fx in a very small manner. I am going to draw the graph of fx. This was the graph of fx that we have drawn. I am going to comment on f double dash x. F dash x we have already commented that graph is always increasing. That means f dash x will always be positive because graph always increases. It never decreases. That means slope will always be positive. But now I need to comment on f double dash x. F double dash x. But every comment I am going to make with respect to fx only. So let's talk about for x between minus infinity to 0. So what kind of graph you are having? Between minus infinity to 0. So this kind of graph we are having. Right? Between minus infinity to 0, this kind of graph we are having. See the graph, this kind of graph we are having. Now let's check the slope here and let's check the slope here. Let me know what will be the slope here. So slope here is 0. Right? Simply you can see that this line will be parallel to the x-axis. Slope here is 0. Here the slope is 0. Here if you draw the tangent, it will become simply perpendicular to x-axis or you can say parallel to y-axis. What is the slope? Sir, slope could be plus infinity as well, slope could be minus infinity as well. I need to see the nature of the graph. Nature of the graph is saying that graph is increasing. That means this slope will be nothing but infinity. Let's draw the slope at some other point. Let's draw the slope at this point. What is this slope? You can see it will be making, I am drawing the slope at this particular point. So how much angle it is making? It is making the angle less than 90 degree, you know. So this slope is positive. You see the nature of the graph. If this is the graph, that means slope is positive. And if this is the graph, that means slope is negative. So if this is the graph, then slope is positive only, no? So yes, slope is positive. So here, what is the scenario? The slope is some positive value, right? So you can see that slope is going from infinity to 0. I am talking about only from x being from minus infinity to 0. So slope is going from infinity to 0. See the nature of the graph. See the nature of the graph. Slope is going from infinity to 0. Slope is going from infinity to plus infinity to 0. Slope is going from infinity to 0. What does that mean? Here the slope is infinity. Here the slope has some positive value. Here the slope has become 0. What does that mean? Slope decreases. Slope decreases as x increases. If the x is increasing from minus infinity to 0, if the x is increasing from minus infinity to 0, as x increases from minus infinity to 0, slope decreases. As x increases from minus infinity to 0, slope decreases. What does that mean? If x is increasing, that means if dx is positive, x increasing means dx is positive, then slope is decreasing. That means slope is decreasing. I am not saying slope is negative. No, slope is positive only. No, basically, if I draw this graph, y versus x. So can I say y is decreasing? Yes, sir. But y is positive. Y is positive, but y is decreasing. No. What is the value of y? Value of y is 5. Value of y is 4. Value of y is 3. Value of y is 2. So value of y is positive, but y is decreasing. Similar thing, slope is positive. We already know slope is always positive, but slope is decreasing. From infinity to 0, the slope is decreasing. So slope is decreasing. That means change in the slope is negative. Do you agree to this point? That means d2y by dx2, d2y by dx2 will be negative. And do we say the same thing? If x is less than 0, then your double differentiation is negative. Aren't we getting the same thing? Say yes or no. So for this particular range, your d2y by dx2 is coming out to be negative. Do you agree to this point or not? A very, very interesting discussion we have done. We will do it for a lot of graphs, but first nature of graph you have seen. What is the nature of the graph? In a rough way, if I make the graph, the nature of the graph was somewhat like this. The nature of the graph was somewhat like this. The graph is increasing, there is no doubt. Graph is increasing means dy by dx is positive. Graph is increasing, no doubt about it. But what about the slope? Here the slope is infinity, sir, and here the slope is 0. Here the slope is 0, sir, and here the slope is infinity. That means slope is going from infinity to 0. Slope is going from infinity to 0. If the slope is going from infinity to 0, what you can conclude? The slope is decreasing. And since the slope is decreasing, with the increase in x, dy by dx is decreasing. That means d2y by dx2 will be d2y by dx square you can say, or d2y by dx2 you can say. So d2y by dx2 will be negative. A very, very important point. We are going to understand the meaning of saddle point or inflection point from here only. Very, very, very important point. Can you comment on the nature of the graph from 0 to infinity? Can you comment on the nature of the graph from 0 to infinity? This time my x is from 0 to infinity. See the nature of the graph. What is the nature of the graph? Somewhat like this. The nature of the graph is somewhat like this. So let me know the nature of the graph. You will draw the slope and you will comment. So draw the slope here. Draw the slope at this point. Which point? At this point you draw the slope. At this point you draw the slope. So if I draw the slope at this point, it will come parallel to x-axis. So this slope is nothing but 0. And if we draw the graph here, then sir it will come parallel to y-axis, or you can say perpendicular to x-axis. Sir, slope could be plus infinity as well, minus infinity as well, but I need to see the nature of the graph. Sir, previously the nature of the graph is increasing nature. That means this slope is infinity. And you can draw the slope at some point as well. Let's just say this point I am drawing the slope. So what kind of slope it is? What kind of nature of the graph it is? The slope is somewhat like this, right? You see the nature of the slope. Slope is somewhat like this. That means this slope is some positive value. So slope is going from 0 to some positive value to infinity. What does that mean? That means here as x increases, increases, slope increases. From 0 to infinity we are going, no? Slope is going from 0 to infinity. That means as x increases, then the slope, what is that? dy by dx. Change in the slope. Dy by dx means change in the slope is also positive. What does that mean? That means d2y by dx2 is nothing but positive only. So if I draw the same graph, or I can comment here only, the slope is going from 0 to infinity. What does that mean? That simply means that, sir, d2y by dx2, as x increases, d2y by dx2 is positive. That means at x equals to 0, what is the scenario? I am drawing the sign of d2y by dx2. Okay, what I am doing? I am drawing the sign of d2y by dx2. I am drawing the sign of d2y by dx2. This is your x equals to 0. For x greater than 0, it is positive. For x less than 0, it is negative. Is that clear to you? Okay, so at x equals to 0, d2y by dx2 is changing the sign. Although this f dash x is not changing the sign. If you draw the graph, if you draw this number line for f dash x, for x greater than 0 also it is positive, here also it is positive. F dash x is not changing the sign, but sir, f double dash x is changing the sign. For x greater than 0 it is positive, for x less than 0 it is negative. Do I need to find out f double dash x? No sir, with the nature of fx only I can tell. What the nature of fx is saying? The graph is increasing, graph is always increasing, but for minus infinity to 0, you can say that, sir, slope is going from infinity to 0. Then the slope is going from 0 to infinity. Infinity to 0, 0 to infinity. Is that understandable? Slope increases, slope decreases. So we are commenting on the nature of the slope, not on the nature of the graph. Nature of the graph we have already commented. What is the nature of the graph? Nature of the graph is increasing. Now we are commenting on the nature of the slope. The slope is nothing but slope is 3x square, right? So if you comment on the nature of the slope, you can simply see that here initially the slope is going from infinity to 0. After that the slope is going from 0 to infinity. Is that completely understandable to you or not? Let's comment on the nature of the graph, what I mean to say. So here, this is the scenario from 0 to infinity we were saying. So one more point we need to discuss. One more point we are discussing. So how the graph look like? I will not make the axis, I am only telling the graph, how the graph is looking like. This point was x equals to 0. So for x less than 0, if you see, isn't the graph looking downward? And for x greater than 0, isn't the graph looking upward? Isn't the graph looking upward? Right? So this much graph is known as concave downward. Okay, and after that this graph is known as concave upward. They are looking upward, no? Concave upward. Concave upward. Concave upward. So for x greater than 0, the graph is concave upward. For x less than 0, the graph is concave downward. So graph is changing its concavity at x equals to 0. So the change in concavity is given by d2y by dx2. The change in concavity is given by d2y by dx2, not by dy by dx. A very, very important point. Some people think that, sir, if here the sign is not changing, no, that means for sure there will be concavity. Yes, it is fine. If f dash x is not changing the sign, no, that means for sure at x equals to 0 there will be concavity, but there could be some other points as well. So when you talk about the change in concavity, what you will care about? You will care about d2y by dx2, not about dy by dx. Did you understand this point or not? So here we have seen that, sir, at x equals to 0, for x greater than 0, the slope was increasing. The slope was increasing, sir. Right? Since the slope was increasing, so d2y by dx2 was positive. And for x less than 0, sir, the slope was decreasing. What does that mean, sir? d2y by dx2 was negative. That means at x equals to 0, there was a change in concavity and d2y by dx2 was changing his sign. d2y by dx2 was changing his sign. Okay, this was the scenario of d2y by dx2. So this d2y by dx2 should also be kept in a box. Right? Understandable? Okay. Well and good. Shall we comment more or shall we move to the new example? We can move to the new example here, or yeah, let's move to the new example. Let's move to this example. Under root x for x greater than 0 and minus under root minus x for x less than 0. Can you draw this graph? Yes, sir. On your own, on my own, I can draw this graph. So do it on your own. For x greater than 0, I need to draw the graph of under root x. Under root x. This is your fx. This is the graph of under root x. And for x less than 0, you need to draw the graph of minus under root x. So take x equals to minus 1, what you are getting? 1 minus under root 1. Take x equals to minus 2, what you are getting? Minus under root 2. Take x equals to 3, minus under root 3. That means it is increasing in this manner. This kind of graph you will get. Is that clear to you? I hope it is completely clear. So this is the graph you will be getting. Without even doing any calculation, comment on the nature of dy by dx. Comment on the nature of dy by dx without even doing any calculation. Graph is always increasing, no? Graph is always increasing. Graph is always increasing. So dy by dx will always be positive only. It will be always positive. You can check. How you can check? Do the differentiation. So what is f dash x? Sir, f dash x is nothing but 1 by 2 under root x for x greater than 0. And what is this? So this will be 1 by 2 under root minus x. And then already there is a negative sign. And then sir, another negative sign comes because of the differentiation of minus x. So this negative sign will become positive sign. Right? For x less than 0. So 1 by 2 under root x, 1 by 2 minus under root x. 1 by 2 under root x and 1 by minus 2 under root x. 1 by 2 under root x and 1 by 2 under root minus x. Both are positive value, no? Put x equals to 1 here positive, put x equals to 2 here positive, put x equals to 3 by 2 positive. This is also positive, put a minus 1 here. Always the value will be positive. So always it is positive. Always it is positive. That means f dash x is always positive. F dash x is always positive. Can you let me know the point where f dash x becomes 0? What I am asking, find out the value of c such that f dash c is 0. Put 1 by 2 and here equals to 0 sign is there, no? So here equals to 0 sign is there. 1 by 2 and root c equals to 0. What is the value of c you are getting? That is infinity. That means there is no finite value. So f dash c is never becoming 0. Right? At x equals to 0, what is the scenario? At x equals to 0. At x equals to 0, what is the scenario? If you put x equals to 0 here, what is the slope? At x equals to 0, at x equals to 0, the slope is infinity, or better I should say undefined. The slope is undefined. Better I should say undefined, not infinity. At x equals to 0, the slope is undefined, because if you put x equals to 0 here or anywhere you put, the slope is coming out to be undefined. Okay, all those points will make some sense. Have some patience. Okay, so at x equals to 0, the slope is undefined, right? But in this particular question, our matter of concern is not f dash x, our matter of concern is f double dash x. So we need to comment on d2y by dx2. But this point is very important for me. I will come back to this point later on. But as of now, you just get to know that at x equals to 0, the slope is undefined, and here f dash x is always greater than 0. It is not greater than equals to 0. This was the scenario. In the previous question, what was the scenario? F dash x was greater than or equals to 0, because it could be 0 as well. Right? At x equals to 0, it was becoming 0. But here in this scenario, it is never becoming 0. It is always greater than 0. Always greater than 0. Always greater than 0, not greater than equals to 0. And at x equals to 0, f dash x is undefined. Let's talk on the nature of the graph. Let's talk on the nature of the slope. What we need to comment on? We need to comment on the nature of the slope. Nature of the slope. So between minus infinity to 0, between minus infinity to 0, see this graph. Okay, between minus infinity to 0, see the graph. What is the slope here and what is the slope here? Let me know the slopes. Sir, if I see the slope here, the slope is coming out to be, it could be plus infinity as well, it could be minus infinity as well. When I see the nature of the graph, sir, graph is increasing, slope is plus infinity. Here, what is the slope? Slope is 0. And in between, if I take some points, sir, and here if I draw the graph, I know that, sir, it is making a positive angle. What does that mean? Since it is making a positive angle, since it is making an angle less than 90 degree, that means slope is positive here. What does that mean? Slope is increasing from 0 to infinity. Slope is increasing from 0 to infinity. What does that mean? Slope increases. With the increase in x, slope increases. What does that mean? d2y by dx2 will be positive. With the increase in x, the graph is increasing, dy by dx is positive, but with the increase in x, the slope is also increasing from 0 to infinity. That means d2y by dx2 is positive. Let's talk about the scenario from 0 to infinity. 0 to infinity. Show me the nature of the graph. So the nature of graph is like this. Nature of the graph is like this. So the nature of the graph is like this. Sir, you don't need to find out d2y by dx2. You can just by looking at the nature of the graph, sir, you can comment. Okay. In the examination, sir, we will do minimum calculation. Even if it is mathematics, forget about the core subject, sir. In core subject, usually we do lesser mathematics only. But here, even in the mathematics, we will do lesser maths. All we do is that we will use our intuition. What is the slope here? 0. Sir, here the slope could be infinity as well, minus infinity as well. I saw the nature of the graph. The nature of the graph says increasing slope is infinity. And in between some points, sir, if I draw the graph, you can say that, sir, it is making an angle less than 90 degree. That means slope is some positive value. What does that mean? Slope is going from infinite to, I should say, slope is going from infinite to 0. What does that mean? Slope decreases. If with the increase in x, if slope decreases. With the increase in x, if the slope decreases, what does that mean? d2y by dx2 becomes less than 0. So if I talk about d2y by dx2, at x equals to 0, the scenario was changing. d2y by dx2, here it is negative and here it is positive. That means at this particular point, something is happening. Can you talk about the concavity? See the nature of this graph. See the nature of this graph. It is looking upward, right? Looking upward. So the graph is concave upward. See the nature of this graph. The graph is looking downward. So this is concave downward. Concave upward and concave downward. So d2y by dx2 is changing its sign. d2y by dx2 is changing its sign at x equals to 0. Now, one point I said in the last lecture, sorry, not in the last lecture, in the last topic here, I said one thing, that it is not necessary that f dash x has to become 0. In this example, basically, at x equals to 0 only, this f dash x was becoming 0 and f double dash x was also becoming 0 at x equals to 0 only. So the point of interest was x equals to 0. Here the point of interest was that, sir, x equals to 0, the things will change. Whether you talk about dy by dx or d2y by dx. But in this scenario, at x equals to 0, what is the condition? Undefined. The graph is undefined. At x equals to 0, the f dash x is undefined. Still, at x equals to 0, what is the scenario we are getting? Still, at x equals to 0, your concavity is changing. That means d2y by dx2 is changing its sign. So this is the point that I wanted to tell. When you talk about the concavity, your matter of concern will not be f dash x. Your matter of concern will become f double dash x. When I talk about the concavity, I am not talking about the nature of the graph. I am talking about the nature of the slope. Nature of the graph, f dash x always positive, increasing. That's it. This is the nature of the graph. Very simple thing. But f double dash x, do you really think that, sir, this fx is given, so I will find out f double dash x, then I will talk about it? No. I will just see fx, I will draw the graph, and I will comment on f double dash x as well. That slope increases, slope decreases. Increasing slope, decreasing slope. d2y by dx2 is negative. d2y by dx is negative. Sorry, d2y by dx is positive here, and then it is negative. Right? Positive, negative. And you can find out d2y by dx2 on your own, and you can see that at x equals to 0, the scenarios will change. Okay? But we are basically, you are having this expression, no? Can you find out f double dash x? Very easily, sir. Can you do the differentiation? 1 by 2, this is x to the power minus 1 by 2. What will be the differentiation? Minus 1 by 2 under root x. So it will become minus 1 by 4 under root x. And what this will become? 1 by 2 is there, and minus x to the power minus 1 by 2. Minus 1 by 2 will come in front. This will become minus 1 by 4. Okay? And then it will become minus 1 by 2, 1 by 2, and minus 1, 1 by 4 under root minus x. 1 by 4 under root minus x. This will be the double differentiation. For x greater than equals to 0, for x less than 0. So this will become always negative, this will become always positive. So for x less than 0, it is always negative, and for x greater than 0, for x less than 0, it is always positive. You can put any value, x equals to minus 1, you put x equals to minus 2, you put it is always positive, and here it is always negative. So you can say that, sir, at x equals to 0, here it is always negative, here it is always positive. But without even finding f double dash x, you should be able to comment. And concavity is changing, concave upward, concave downward. So wherever the graph changes its concavity, that point is known as point of inflection, not a saddle point. What I am saying? Point of inflection, not saddle point. Sir, what is this saddle point? We will discuss about it. But usually the doubt is that always people think that saddle point and point of inflection are same. That is absolutely baseless. Point of inflection and saddle point are two different concepts. If I am the examination setter, no, then from differential calculus I will only ask this thing. I will frame a question which I have already framed here, and I will ask you whether the x equals to 0 is a saddle point or inflection point. People will think, okay, both of them are same, they will click on it. At x equals to 0, your f dash x is undefined. At x equals to 0, your f dash x is undefined, right? So it cannot be a saddle point. So here x equals to 0 is not a saddle point. Although in the previous question, here in this scenario, saddle point and inflection point are same. So we will do the discussion, but as of now, you just need to care about only one thing. What is that? Am I able to comment on d2y by dx2 or not? Yes, sir, you are able to comment on the d2y by dx2. Your job is done. Graph increases, but the slope is decreasing. Slope is increasing. Here it was negative, here it was positive. In the next graph, what I saw? In the next graph, I saw that graph increases, but slope here is increasing, then slope is decreasing. d2y by dx2 is positive, d2y by dx2 is negative. This much I need to comment. And where the concavity is changing, looking upward, looking downward, where the concavity is changing, that point is known as point of inflection, and it is not the saddle point. Okay, saddle point and point of inflection are two different concepts. Let's go to the next question. Fx equals to minus x cube we need to comment, and everything we need to comment just like the previous scenario. So it's up to you. You should be able to write down everything without even doing any calculation. I will not find f dash x, I will not find anything else. Just comment on everything. You need to comment on slope as well. You need to comment on the nature of the slope as well. What you see, graph is always decreasing. Increasing, decreasing is always decided from minus infinity. I have told this thing 100 times. Whenever we talk about increasing or decreasing, we will always start from the left hand side. So it is always decreasing. So graph is always decreasing. What does that mean? Sir, without even doing the calculation, I can say that for sure my f dash x will come out to be less than 0 only. Whether it will be equal to 0 or not, that I cannot say. Whether it will be equal to 0 or not, that I cannot say, but I am pretty sure that f dash x would be less than 0. It could be equal to 0 as well, but when I differentiate, I got to know that it is coming out to be minus 3x square. So yes, it could be equal to 0 as well. Since the graph is always decreasing, so this is equal to 0. Now let's talk about the nature of the slope. Here if you draw the slope, I am only talking about this much graph. Sir, slope could be plus infinity as well, minus infinity as well. Sir, I cannot comment. What will be the slope? Since the graph is decreasing, no, so here the slope will be minus infinity. Here the slope will be minus infinity. Since the graph is decreasing, at this particular point, what will be the slope? At this particular point, the slope will be 0. At this particular point, the slope will be nothing but 0. At some point in between, you draw the graph. The graph will look somewhat like this. Not the graph, you draw the slope, sorry. At some point in between, you draw the slope. Are you able to see it or not? The graph is decreasing, so I can show it like this. At some particular point, I am drawing the slope. So what kind of slope you are getting? So slope is making more than 90-degree angle, no? You can see this nature. Here the slope is coming like this, right? The slope is coming like this. You can see the nature, decreasing nature it is, no? It is making 90-degree angle. Previously the slope was becoming like this. The slope was like this. Increasing nature it was having, and it is making less than 90-degree angle. Now it is making more than 90-degree angle. That means this slope is negative only. The slope is negative only. This slope is nothing but negative. This is some negative slope. This is what? This is some negative slope. The slope is going, that means the slope is going from minus infinity to 0. Is it increasing or decreasing? Minus 4 is larger or minus 2 is larger? Minus 2 is larger, no? Minus 100 is larger or minus 1 is larger? Minus 1 is larger. So slope is going from minus infinity to 0. What does that mean? Slope increases, right? Slope is increasing. Slope is increasing. That means with the increase in x, slope is increasing. What does that mean? d2y by dx2 is positive. Say yes or no. Is this clear to you or not? Here the slope was minus infinity. From minus infinity to 0 the slope is going. What does that mean? The slope is increasing or decreasing? The slope is increasing. Let's talk about the nature here. Sir, here what will be the slope? At x equals to 0 the slope is 0. Here what will be the slope, sir? Here what will be the slope? So slope could be plus infinity as well, minus infinity as well. I don't know. So what I saw, the graph is decreasing. The graph is coming decreasing. That means slope will be minus infinity. At this particular point, if I draw a slope, what do I see? Sir, here if I draw a slope, again I see that slope is having decreasing nature. Slope is having decreasing nature, or I can see that it will be making some angle greater than 90 degree. What does that mean? This is some negative slope only. This is some negative slope only. This is some negative slope only. So the slope is going from 0 to minus infinity. Here the slope is going from 0 to minus infinity. What does that mean? 0 to minus infinity. 0 to minus infinity, 0 to minus 1, minus 2, and then minus infinity. What does that mean? Slope is decreasing. If the slope is decreasing, then what will be the scenario? That d2y by dx2 will be negative. What does that mean? Sir, at x equals to 0, again your d2y by dx2 is changing the sign. At x equals to 0, again it is changing the sign, and you can sense one thing, sir. What you can sense here? That, sir, concavity is also changing. This graph is looking upward. You see this graph? This graph is looking upward. So this is concave. This much nature is, if you talk about this nature, how do I show here? Here I am showing it is looking concave upward. The graph is looking concave upward. And if you see this nature, this graph is looking concave downward. Concave downward. Right? Concave upward and concave downward. Concave downward. Okay? So concave upward, concave downward. Concavity is changing at x equals to 0. So can I find out this point? How will I find out this point? So this point will be found out using double differentiation, not the single differentiation. So you will be commenting on d2y by dx2, not on dy by dx. Is that understandable to you or not? Someone will say that, sir, if I put this equals to 0, then x equals to 0 is the point of inflection. Absolutely baseless. Yes, it is the point of inflection, but your method is wrong. What method says? Method says that point of inflection will be that point where d2y by dx2 is changing the sign. That's it. This is the meaning of point of inflection. So, sir, this will be the point of inflection. Point of inflection. Okay. We are going to take a very good interesting example where point of inflection and saddle point will be different, and using f dash x you will not be able to find out the inflection point. Usually what people think is that, okay, you need to find out the saddle point, you need to find out the inflection point, both are same. Put f dash x equals to 0, whatever the point you are getting, that is saddle point and inflection point. Absolutely baseless thing. What do you mean by stationary point then? What do you mean by critical point then? Even critical point and stationary point are different. No, if they are giving two different names, but that means they are having different definition. So don't confuse. Whatever that you have studied previously, forget that everything. Forget everything whatever that you have studied previously. You are studying new things and corrected thing. To the point, everything will be corrected. Every single definition, every single meaning will be absolutely clear and absolutely correct as well. Okay. Here we may do some minor mistake in the calculation, but conceptual error will never happen on this platform. Never ever conceptual error will happen. Only some calculation mistake might be there. Understandable? So you can comment on the nature of the slope as of now. Everything is crystal clear. From minus infinity to 0, then 0 to minus infinity. Absolutely clear. As of now, everything is clear, sir. Let's talk about the next point, sir. I need to discuss everything like the previous question. Can I draw the graph? Draw the graph on your own. Yes, sir. Drawing the graph, I would get to know the graph would look somewhat like this. Minus under root x. If you put x equals to 1, minus under root 1, minus under root 2, minus under root 3, minus under root 4, minus under root 5. And here if you put under root 1, under root 2, under root 3, under root 4, there you go. This will be the graph. Graph always decreases. What does that mean? Graph always decreases. You can see graph is always decreasing. Since the graph is always decreasing, can I comment on the nature that f dash x is always less than 0? Okay. F dash x is not changing its sign. F dash x is always less than 0. Previously, what was your f dash x? F dash x was less than or equals to 0. Here, what was your f dash x? F dash x was greater than or equals to 0. So, f dash x is not changing the sign, but let's talk about f double dash x. F double dash x. What is the slope here? So, slope is infinity. The slope is infinity or minus infinity, we will comment on that. What is the slope here? The slope here is nothing but 0. So, here the slope is 0, sir. Here the slope is 0. And what is the slope here? The graph is decreasing, no? The graph is decreasing, slope is minus infinity. Take any point in between, draw the slope. What do you think? What is the slope we are getting? It is making an angle greater than 90 degree. That means slope is negative only. What does that mean? In this region, the slope is going from minus infinity to 0. Slope is going from minus infinity to 0. What does that mean? To 0. What does that mean? Slope is increasing. Slope is increasing. So your d2y by dx2 will become, with the increase in x, slope is increasing, so it will become positive. And here what will be the scenario? Slope is 0. Slope is 0 and slope is infinity. So here the slope will become infinity or minus infinity. Graph is decreasing now, the slope is minus infinity. Here the slope is negative. So slope is going from 0 to minus infinity. m is decreasing, then what will happen? d2y by dx2 will become negative. That means at x equals to 0, the scenario is changing. At x equals to 0, the scenario is changing. Here it is negative, here it is positive, right? Okay, so d2y by dx2, so negative and positive here. Okay, so this is the point where slope changes. Slope goes from, slope increases and then slope decreases. Okay, so at x equals to 0, the nature of the slope is changing, right? And you can see what is the nature here: concave upward, concave downward, right? So what this is? Concave upward, and what this is? This is concave downward. Say yes or no? Concave upward, concave downward, right? And d2y by dx2 is changing its sign at x equals to 0. It is positive and it is negative. So if the concavity is changing, then d2y by dx2 will be changing its sign. Understandable? Well and good. Let's see the conclusion. Just talk about the d2y by dx2 sign here. Here the graph is changing, here the nature of the graph is changing, here also it is changing, here it also it is changing. So I am putting concave upward, this is concave downward, this is concave upward, and after that concave downward. This is concave downward, this is concave upward, this is concave downward, and this is your concave upward. Talk about the nature of the slope. Sir, here the slope is infinity, here it is becoming 0. That means slope decreases. Here, if I talk about d2y by dx2 sign, I am drawing the graph of d2y by dx2. d2y by dx2 sign I am talking about. d2y by dx2. Slope decreases, then increases. Right? Slope infinity to 0, then 0 to infinity. All these things I have already explained in a great manner. So I don't think I need to explain here again and again. What about this one? Here the slope from 0 to minus infinity is going. 0 to minus infinity, that means slope is decreasing, and here it is increasing. Right? What about this one? From 0 to decreasing nature, no? So from 0 to minus infinity, that means here the slope is decreasing and here it is increasing. And this is your minus infinity, and minus infinity to 0 it is going. Minus infinity to 0 it is going. So that means decreasing and increasing. And here it will have positive and then negative sign. From from infinity to 0, infinity to 0, and here from 0 to plus infinity. So this much graph you should be able to draw on your own. Okay, you should not be looking at the solution what I am saying. So one thing you can notice is that if the nature of the graph is concave downward, no, then d2y by dx2 is negative, otherwise it is positive. Basically, if the nature is concave downward is showing negative. It is showing negative, and here it is showing positive. Concave upward is showing positive, concave downward is showing negative. Concave downward is showing negative, concave upward is showing positive. And concave downward it is showing negative, and concave upward is showing positive. Do you need to mug it up? No. In the examination, even if they ask you that the nature of the graph is concave upward, what will be the value of d2y by dx2? What you can do is that you will simply make the graph, okay sir, concave upward, sir, concave upward. This will be the nature of the graph, concave upward, looking upward, or this would be the nature of the graph, concave upward, right? Anything could be the nature of the graph. Sir, if this is the nature of the graph, you can see that this will be m equals to minus infinity. Why is that so? Because graph is decreasing, and this will be m equals to 0. So sir, minus infinity to 0, that means nature of the graph is, sorry, the slope is increasing. Slope is increasing, that means d2y by dx2 will be positive. What about this, sir? Here the graph is 0. Here the slope is 0, and what will be the slope here? Sir, it could be plus infinity, minus infinity. I see then the graph is increasing, that means slope will be plus infinity. So from 0 to infinity, again the slope is increasing. What does that mean? d2y by dx2 will be positive only. So for concave upward, the d2y by dx2 value will be always positive. There you go. Okay. So you don't need to mug up all these points. If they are asking these points, then you can draw the graph and tell the nature of the d2y by dx2. So now the point where d2y by dx2 is changing its definition, changing its sign, that point is known as point of inflection. So this is the definition that is written. Inflection point, the point where d2y by dx2 changes the sign, that is point of inflection. What is the saddle point? saddle point is that point where dy by dx does not change the sign. Let's just say I find out dy by dx, f dash x I find out. That is coming out to be x square into x minus 2 into x minus 3. So what I will do? 0, 2, 3. Change sign, change sign, change sign. Here the sign will not change, no? Right? Because it is even power. So this point is known as point of a saddle point. This point is known as saddle point. That's it. It has nothing to do with d2y by dx2. It has nothing to do with d2y by dx2. So saddle point is defined from f dash x. Okay? And the inflection point is defined from d2y by dx2. And every saddle point will surely be inflection point. As of now, you are not able to understand this point, but with this example, you will be able to understand. But one line I am writing down: every saddle point is a point of inflection. But it's converge, but not vice versa. What is the meaning of vice versa? That means the statement cannot go otherwise. Or let's write down: but every point of inflection is not a saddle point. Is that clear to you? Okay. So this much theory is clear to you. This point is not clear to you. It will become clear. But as of now, you have understood the meaning of point of inflection. So whatever our previous discussion was there, that was based on only one scenario, that was the point of inflection where the concavity is changing. Okay, let's discuss this particular graph. So fx expression is given. So what I could have done is that I would have simply given the fx expression, and then I could have asked these points, that it is global minima, global maxima, all these points I could have asked. But what I saw is that this graph was pretty difficult actually. Okay, this graph was pretty difficult to draw. So I have given f dash x as well, I have given f double dash x as well. When you differentiate this graph, no, then you would get f dash x. When you differentiate this one, you will get f double dash x. Okay, so differentiation was actually a bit difficult point. That's why I have given all the values, and now you need to comment. So we know the value of fx, then we know the value of f dash x as well. So what is our f dash x? Sir, f dash x is, if I need to draw this graph, what I will do? You will differentiate, sir. Once you differentiate, what value I will be getting? 4 into x minus 10 whole square, x plus 5, 3x square plus 100. Now what I need to find out? I need to find out its root. What I need to find out? I need to find out the roots. So one thing I can sense, that root will be 10, root will be 5. Sorry, minus 5. Minus 5 will be one of the root, 10 will also be one of the root. From here any root will come? No. 3x square will never be 0. 3x square plus 100 can never be 0 for any real x. What will be the value of x? Sir, value of x will come out to be minus 100 by 3 under root. Is this value real? No, it is imaginary value. So for any real x, this will never be 0. So at 10, after 10, for x greater than 10, f dash x will be positive. At 10, will it change the sign? No, sir, because there is a even power. Here it will change the sign. There you go. So what do you think, what kind of graph you will be getting? So the kind of graph you will be getting is, graph is decreasing and then increasing, and then, sir, again it will be increasing only. This kind of graph you will be getting. Is that clear to you? Decreasing, this point is minus 5, this point is minus 5, and this point is 10. So, sir, decreasing, increasing, and then increasing. So from here, if I point, if you see the graph, you can sense one thing, that this particular point will be the point of minima, because the graph is starting from plus infinity. In that manner it is starting, and it is going towards infinity only. So this is the point of minima. So x equals to minus 5 is the point of global minima. Yes, sir, this is the minimum possible value we can get. Yes, it is the global minima. X equals to 2 and 10 are the two inflection points. Sir, I can see only one inflection point. At this particular point, the graph is not changing, no? So, sir, only one inflection point is there. That means this should be incorrect. No, it could be correct. What did I say? Inflection point means where d2y by dx2 is changing its sign, not dy by dx. We only find out dy by dx. So where d2y by dx2 is changing its sign, that is known as point of inflection. Okay, not where dy by dx is changing its sign. Are you able to understand this point? So x equals to 10 is the only saddle point. This particular thing is correct, because here f dash x is not changing its sign. So this particular point is saddle point. It will be surely point of inflection as well, but there could be other point of inflection as well. The graph may change its concavity some other point as well. There could be some other points as well where the graph can change its concavity. What I mean to say is that, sir, as of now, according to us, this will be the graph till first differentiation. When I have done the first differentiation, if I say, sir, this point is -5 and this point is 10, sir, according to my definition, the scenario will go like this. The graph is decreasing, then it will be increasing and always increasing, but at this particular point, it is changing its concavity. Previously, it is concave downward, then it is concave upward, right? According to my definition, according till f dash x, I can conclude this much. But is this always correct? Is this completely correct? Let's find out by double differentiation. When I double differentiated it, what I got to know that the value is coming out to be 60x square, 60x square into x minus 10 into x minus 2 into x minus 10 into x minus 2. So, sir, where are the roots? Roots are at 0, 2 and 10. 0, 2 and 10. So, sir, where f double dash x becomes 0, then all these are the inflection point. Inflection points. Wrong. What is the definition of inflection point? Where d2y by dx2 is changing the sign. Sign should change, no? Negative to positive, positive to negative, positive to negative, negative to positive. Sign should change, then only the concavity will change. So, are we changing the sign at x equals to 10? For x greater than 0, f dash x will be positive. Yes, sir. Here, negative. Here, positive. And here, since even power is there, again positive. So, if your f double dash x is positive, what does that mean? The nature will be concave upward. Then the nature will become concave downward, and then the nature will become concave upward. Although the graph is always increasing, the graph is always increasing. At this point, what is the nature of the graph? Graph is always increasing, but concavity is changing. Okay, at x equals to 0, the concavity is not changing. Here it will be concave upward only. Till this point, the graph will be concave upward only, since it is positive, no? I told you d2y by dx2 is positive. If d2y by dx2 is positive, then the graph is concave upward. So, the graph will be concave upward only. The graph will be concave upward only. Always it is concave upward. But here it will become concave downward. So, here the graph is becoming concave downward. Here it is concave upward. Always. Here also it is concave upward. Always it is concave upward. And here it will become concave downward. Sorry, not concave downward. Since d2y by dx2 is positive, so it will become concave upward. So, where d2y by dx2 is changing the sign, here it is changing the sign, here it is changing the sign. So, point of inflection are x equals to 2 and 10. Okay. And what is the saddle point? For saddle point, you don't care about d2y by dx2. For saddle point, only you care about only f dash x. So, I care about only f dash x, and at f dash x, what I got to know is that in f dash x only there is one point where it is neither maxima nor minima. So, this particular point is x equals to 10. This particular point is neither maxima nor minima. That means f dash x is not changing its sign. That means this is the saddle point. Is the definition correct to you? So, point of inflection is 2 and 10. Point of inflection is 2 and 10. But this is not the point of inflection. X equals to 2 is not the point of inflection. Sorry, x equals to 2 is not the saddle point. Only x equals to 10 is the saddle point. Okay, so this is the actual graph you will be getting. The graph goes like this, and you can see between this is the point x equals to 2. So, here the concavity is changing. Although in the graph it is not visible, but actually the concavity is changing. So, this was concave upward. The graph is concave upward here. Always it is concave upward. Then the graph is looking concave downward. So, you can see here the graph between till this point it will be concave upward, then it will become concave downward, then concave upward. So, there are 2 points where concavity is changing. So, I can write down, I can show here that in this much of a portion, or looking from all the points, here concave upward nature you are getting. Look, this nature is also concave upward only, no? The graph is looking upward only. This much nature is also concave upward. So, looking from minus infinity to 2 till this point, the nature is concave upward. Then in this much portion from 2 to 10, the nature is concave downward. And after that, again it is concave. I don't know what is the spelling, concave or concave, whatever it is, concave upward again. So, at 2 points we are changing the definition. At 2 points we are changing the definition, and these 2 points are x equals to 2 and x equals to 10. So they are known as point of inflection, and this is known as saddle point as well. Why it is saddle point? Because it is, why it is known as saddle point? It is known as saddle point because here f dash x is not changing its sign. Okay, f dash x is not changing its sign. F dash x is becoming 0, but it is not changing the sign. That means it is neither maxima nor minima, and this is your global minima. Why it is global minima? So because it is giving the least possible value, that's why it is global minima. Solve this question on your own. You need to find out the saddle point and point of inflection. That's it. Do it on your own. Don't mess it up. I hope you will be able to do it on your own. I need to take a break. I will drink some water and then I will come back. We will solve this question and then you need to solve this question as well. Think about it. Take your time. Use your brain. This is actually a concept. It is not a question. But since I have given you so much of concept, since I have given you so much of depth, I guess you will be able to comment on f double dash x at the point of local maxima and minima. Okay. So have some patience. Think about this question and try doing it on your own, and do this question as well. I will take a break and then I will come back, and I hope you will be putting up a like for this kind of concept clarity and for this kind of concept depth. Okay, so put a like and try solving these questions. Yeah, so did you solve this question? What we need to do, we need to find out the saddle point and the point of inflection. So first what we will do, we will find out the f dash x. What we are getting, 5x to the power 4, so it will become x to the power 4 minus 18x square plus 81, that will be differentiated to 0, right? Now what we need to do is that x square we will take common, so x square minus 18. So what all roots we are getting? We are getting 3 roots. The roots are 0 plus under root 18 and minus under root 18. Minus under root 18 and plus under root 18. So plus minus, but here the sign will not change because 0 is coming twice. Even power is there, so sign will not change, and here the sign will change. That means the graph will increase, then it will decrease. There will be saddle point and then it will increase. This kind of nature of graph would be there, but it will change the concavity as well. In between, the concavity will also change. One point we have noticed is that at x equals to 0, yes, the slope is 0, but at x equals to 0, f dash x is 0, but it is neither maxima nor minima. This was a local maxima, this was a local minima, but this point is nothing. Here neither maxima nor minima. What does that mean? Basically here, but no sign change. I will simply write down, but no sign change. No sign change. What does that mean? X equals to 0 is the saddle point. So saddle point we have got. But if they ask about the point of inflection, what I will do? For finding out the point of inflection, sir, what I will do is that I will do the double differentiation. So when I do the double differentiation, what answer I am getting? When I double differentiate it, I am getting 4x cube minus 36. This is the double differentiation, no? Minus 36x, right? Here if you differentiate, it will become 4x cube and this will become 36x. So what you are getting? You are getting 4x as common. Inside you are getting x square minus 36. No, not 36. X square minus 9. Understandable? 4x you are getting common, so x square minus 9. You did the double differentiation. What is the double differentiation? That will become 4x cube minus 36x. So from here, x equals to, what all are the roots you are getting? 4x into x plus 3 into x minus 3. This is the scenario you are getting, and now you can sense where the sign would change. So this is x equals to 0, this is plus 3 and minus 3. So sign is, this is minus 3, this is plus 3. So since all are having the odd power, everywhere the sign would be changing. Right? So sign would be changing here as well, here as well, here as well. In this region, what will be the nature of the graph? Since it is negative, so it will be concave downward. This will be positive, concave upward. This will be negative, concave downward, and this will be positive, concave upward. And what will be your point of inflection? So x equals to 0, x equals to minus 3, 0, 3 are the point of inflection. What they are? They are the point of inflection. Okay. So you can draw the graph, but drawing the graph will be a bit difficult. And this will be somewhat 4 point something, and this will be somewhat 4 point something as well. You can draw the graph, but concavity is changing at 3 points, so a bit difficult it would be to draw the nature. What I mean to say is that minus under root 18 will be somewhere here. This will be minus 3. This will be 0. Then you will get 3. Then you will get under root 18. fx of x. You know that at minus under root 18 and plus under root 18 you will get maxima and minima. So this thing we know. but concavity will change, At what point concavity will change? Concavity will change at -3. So till this point it will be concave downward. Now even if it is decreasing, it is concave downward. Now it will decrease only, but the graph will become concave upward. So graph will become concave upward. It is concave downward as of now. Now it will become, here the concavity will change, So it will become concave upward. Concave upward. Right? After that what will happen? Graph will decrease only, but at 0 the value is 81. At x equals to 0 the value is 81. So I need to show it somewhat like this. Concave upward. Then the graph will, here the graph is decreasing only, the graph will keep on decreasing, but the nature will change. It will become concave downward. Concave downward it will become. Okay. Then what will happen is that here the graph will increase at x equals to 3. At x equals to 3, the graph will keep on decreasing only, but the nature will become concave upward. It will keep on decreasing only, but the nature will become concave upward. Okay. And after that what will happen? The graph will increase, but the nature will remain concave upward only. This kind of graph you are getting. This kind of graph you will get. So you can plot it in any software. This kind of graph you will be getting. Although making a graph is not a matter of concern. Only thing is that you can comment on the concavity. Here I could have made it a bit more better. Between -3 to 0 the graph is concave upward. So I will make it concave upward only. And then the graph is concave downward. I will make it concave downward. Somewhat like this. So here concave downward, you can see that graph is looking inside. So this much nature is concave downward, or here I can show concave downward. This much nature is concave upward. No, concave upward till x equals to 0 only. Till x equals to 0 only. This much is concave upward. Then the nature is concave downward. Then again it is concave upward. And now what about increasing and decreasing? So till this point it will increase. Here the graph is increasing. Right? After that graph is decreasing only. Graph is always decreasing. And then the graph will increase. Right? So in this point, till this point graph is increasing. Then from here to here, till this point graph is decreasing. Then after this point graph is increasing. Okay. Increasing, decreasing, increasing, concave downward, concave upward, concave downward, and then concave upward. So if they ask you anything about any graph, will you be able to comment? Absolutely, sir. You ask me anything about any graph, I will be able to comment. Point of inflection is -3, 0, 3. What I will do is that I will double differentiate, put that equals to 0, and I will see at what point the graph is, at what point d2y by dx2 is changing its nature, plus minus plus minus. So they are the point of inflection, and this is the saddle point we are getting. And now you can see one thing, whatever the saddle point is there, that is surely the inflection point. There is only one point which is saddle point as well, and it is inflection point as well. So whatever the saddle point is there, that will be surely be an inflection point. This is what I have written here. Every saddle point is a point of inflection, but every point of inflection is not a saddle point. If I ask you at x equals to -3, if I ask you x equals to -3, it is the point of inflection, but it is not a saddle point. So both are different things. Is that clear to you or not? I hope it is completely clear to you. Understandable? All good? All fine? Yes. Okay, let's proceed to the next question. It is a, like, usually it is taught as a concept, and they will not even teach it as a concept. They will ask you to remember it. But I have made it a question, and will you be able to solve this question or not? So what is given? Y equals to fx is given. So there was this function y equals to fx. When I differentiated this function, and put that equals to 0, then what I got to know is that value of x was coming out to be x1. Okay. When I differentiated and put that equals to 0, then the value of x came out to be x1. This is what it is written, that f dash x1 is 0. Is that clear to you? Now which of the following statement are true? If f double dash x is greater than 0, then x equals to x1 will be a point of local minima. What is local minima and what is local maxima? Sir, this is the graph of, this is the point of local minima, and sir, this is the point of local maxima. Is that clear to you? So let's talk about local minima. What do you mean by local minima? If your x equals to x1 is local minima, they are saying it. This is the point x equals to x1, right? At x equals to x1, what is the slope? Let me know what is the slope. At x equals to x1, the slope is 0. And after that, what is the slope? Just after x1, just after x1, just after x1. Can you let me know the slope? Slope is negative, no? What I will do, I will draw the graph a bit larger. This point is x equals to x1, and this point is x equals to, this point is x equals to, this is x equals to x1, and this is x1 plus dx. That means I am increasing the x1 by a small amount. So here what is the slope? So this is the point of okay, this is the point of maxima we have drawn. Okay, so we are discussing the point B as of now. We are discussing the point B because the point of maxima I have drawn. No, so here the slope is 0. That's what I already know. Here the slope is 0. What will be the slope at this point? At this point, if you draw a tangent at this point, what will be the slope? What will be the slope here? So slope is some negative value. Slope is some negative value. It is making some angle greater than 90 degrees. So slope is some negative value. Right? So what has happened? If dx was positive, with the increase in x, what you have got? The change in slope. The change in slope is negative only. What you have got from 0 to some negative value, from 0 to some negative value, m is going from 0 to some negative value, some negative value. What does that mean? What does that mean? That means m has decreased. Say yes or no? M has decreased. What does that mean? If m has decreased, what does that mean? That means this has to be negative. That means d2y by dx2 has to be negative. There you go. So what they are saying, if f double dash x1, and all we are talking about is at x equals to x1, so f double dash x1 has to be negative or less than 0. So if f double dash x1 is less than 0, then x equals to x1 is a point of local maxima. Absolutely yes. Is that clear to you? Same goes for local minima as well. Do it on your own. Draw the graph. We are talking about minima. I will draw the graph in this manner. X equals to x1 is my point of minima. X equals to x1 is my point of minima. Then take nearby point only, although it will look far, but it is actually near only. Okay, draw the slope. This is x1, this is x1 plus dx. Draw the slope. Slope here is 0, and what is the slope here? Slope here is some positive slope you are getting. So what is the slope here? Slope is 0, and here some positive slope you are getting. What does that mean? From 0 to positive slope, 0 to some positive value. Let's say the slope goes from 0 to 2. What does that mean? Slope increases. That means here m is increasing. M is increasing. If dx is positive, then m increases. Or you can say change in dy by dx. Change in dy by dx is positive. Change in dy by dx is positive. So what does that mean? d2y by dx2 will be nothing but positive. That means f double dash x2 will be greater than 0. So at the point of minima, or maxima, can you comment on the value of d2y by dx2? Absolutely, sir. At the point of minima, the double differentiation will be positive, and at the point of maxima, the double differentiation will be negative. We will verify it. And if your double differentiation is 0, then it will be a point of inflection. No, not necessary. If your double dash x is 0, then it will be a point of inflection. It is not necessary. Why is that so? If your f double dash x is 0, it has to be a point of inflection. Is it necessary or not? No, it is not necessary. This option is correct. Why it is not necessary, we will talk about it. Have some patience. We will take example and we will talk about it. Or can I explain in other manner? Yes, I can explain. Okay, let's take up a graph like this. Okay, let's take up example for option C. I am taking example fx equals to x to the power 4. Okay, x to the power 4. So can you find out f dash x? Yes sir, it will become 3x cube. When it will become 0? Sir, it will become 0 at x equals to 0. That means this is our x1 only, right? F dash of x1 is equals to 0. So what is the value of x1 here? That is 0 only. Now double differentiate it. If I double differentiate, what I am getting? 9x square. So if I put this x1 equals to 0 here, what is the value I am getting? 9 into 0, that is equals to 0 only. That means you are expecting that x1 equals to 0. It should be a point of inflection, right? As per the option C, it should be a point of inflection. As per the option C, it should be a point of inflection. Point of inflection. But is it a point of inflection or not? No, it is not a point of inflection. Why is that so? Because 9x square, it will never change the sign. Never changing the sign. At x equals to 0, it is not changing the sign. No, not changing the sign. What does that mean? I am saying that f double dash x is 9x square. Where are the roots? Sir, the root is at x equals to 0. At x equals to 0. But if you see one thing, for greater than 0 as well it is positive, for less than 0 as well it is positive. That means here as well it is concave upward, and here as well sir it is concave upward only. So the nature of the graph is always concave upward, always concave upward. But what about the slope? The slope came out to be 3x square. Sorry, 3x, sorry, what I am doing, 4x cube. Sorry guys, the slope came out to be 4x cube. Slope came out to be 4x cube. So if you talk about the slope, then the slope will be like this. For x greater than 0, here the slope will be positive and here the slope will be negative. That means first the graph will decrease and then increase. Here the graph will decrease, and then it will increase. Right? Graph will decrease and then increase, but making the concavity always looking upward. So what kind of graph you will be getting? Concavity will be always looking upward. The graph you will be getting is somewhat like this. Graph should decrease, but concavity would be upward. Graph should be decreasing, but concavity would be upward, looking upward. Then graph should be increasing, but concavity should be looking upward only. So you can see looking upward, right? Looking upward. So always it is concave upward only. But here what is the scenario? Here what is the scenario? Graph decreases, and here the graph increases. So for this situation, what you will be getting? You will be talking about f dash x. You will be talking about f dash x. So here f dash x is positive, here it is negative. So this you are talking about f dash x. And here what you are talking about? For this scenario, what you are talking about? You are talking about f double dash x. In both of the scenario, graph is concave upward. So here it will be positive only and it is positive only. So x equals to 0. This x equals to 0 is neither the saddle point, nor it is point of inflection. What actually it is? It is actually the point of minima, right? X equals to 0 is actually the point of a minima. But at x equals to 0, your f double dash x was actually coming 0. So if your f double dash x has become 0, then either it could be point of maxima, minima, inflection, or saddle point. You cannot conclude. Are you able to understand this point? That's why this option is wrong. If your f double dash x has become 0, you cannot conclude whether it will be maxima or minima or point of inflection or saddle point. You cannot conclude actually. Is that clear to you or not? Okay. So actually it turned out to be the point of a minima. Are you able to understand this point? So even if your differentiation is, even if your double differentiation is 0, it could be point of minima as well. It could be point of a maxima as well. Or it could be point of inflection, or it could be a saddle point. You cannot comment. Is that clear to you or not? Are you mugging up anything? No, you are not mugging up anything. Let me frame example. It will be more clear to you. I will frame example. So let me think of the example first. So this is x square. I will take x minus 2. I will take x minus 3. I will take. So this will become x square minus, I am thinking of the example, just have some patience. 5x plus 6 multiplied with x square, this will become x to the power 4 minus 5x cube plus 6x square. So what will be my fx? I am writing down a question. The question is your fx is x to the power 5 divided by 5 minus 5x to the power 4 divided by 4 plus 2x cube. Is that clear to you? Yes. Okay. Then what you need to comment on? You need to comment on maxima, minima, point of inflection and everything. Okay. So comment. Question is comment. Comment. Using the previous scenario, using this particular thing. Not about our, not the way we do, but we need to use the previous scenario. What I need to do is that first I will do f dash x. First I will find out f dash x, what I am getting. X to the power 4 minus 5x to the power 3 plus 6x square. So what I will take x square as common. This will become x square minus 5x plus 6. So what I am getting x square, x minus 2, x minus 3. Right? This is the scenario I am getting. Although if I want to analyze on my own, then I will be able to analyze it, which is this is 0, 0, 2, 3. Here sign will change, here sign will change, sign will change, but sign will not change. So graph will be increasing, then it will be decreasing, and then it will increase. This kind of a scenario will be getting. So this is the x equals to 2 is the point of a local maxima, and this will be the point of local minima. But I don't want to do the analysis in this manner. What analysis I want to do? So I have got 3 points. My point of consideration are 0, 2, 3. These are the point I am interested in. 0, 2, 3. These are my matter of concern. What I am writing? Matter of concern. And this, what will be x equals to 0? This will be the point of inflection. Point of inflection. Point of inflection or saddle point, whatever you can call it. Along with that, you can call it saddle point as well, or better, let's call it saddle point. It will be point of inflection for sure, but if I have called it saddle point, then surely it will be a point of inflection. So let's call it saddle point. Now my matter of concern is 0, 2, 3. So what I will do? I will find out f double dash x. What will be my f double dash x? Sir, f double dash x will be nothing but 4x cube minus 15x square plus 12x. Say yes or no. 4x cube minus 15x square plus 12x. Now find out f double dash x at x equals to 0. If you put x equals to 0 here, what is the answer you are getting? 0 only. No conclusion can be made. No conclusion can be made. Okay. Now what I do? F double dash x I am finding at x equals to 2. At x equals to 2. What you are getting? 4 into 2 cube minus 15 into 2 square plus 12 into 2. So this will be 8, 32 minus 60 plus 24. What answer you are getting? Minus 6, which is less than 0. That means it is the point of maxima. So x equals to 2 is the point of maxima. Is that correct? Yes, sir. X equals to 2 is the point of maxima. So this is how usually people analyze it. They don't even make this graph. What they will do is that f dash x, then they will mug it up. No, like they will not even have this kind of clarity. What they will do is that they will simply mug it up. Okay, f dash x I will find out. We will find out these points. Then put x equals to 0 here. No conclusion. Put x equals to 2 here. It is coming out to be negative. That means it is the point of maxima. If it comes out to positive, it is the point of minima. That's it. Then second derivative test, third derivative test. Like you are an engineer, no? Right? You are not a JEE student. Right? You are preparing for an engineering examination, not for some JEE examination. If it was JEE Advanced or JEE Mains, then I would have taught in a separate manner, but it is your engineering examination. So let's prepare it like an engineer. Okay. F double dash x at x equals to 3 we will calculate. So whatever the value we get, so 4, 3 cube minus 15, 3 square plus 12 into 3. Plus 12 into 3. So what answer we are getting? This will be 27. Right? 3 cube will be 27. And 27 into 4. 108. 108 minus 9. 15 into 9. 150. 150 minus 9. Sorry, 150 minus 15. That will become 135. Plus 36. right? So 1 here, it is coming out to be 9, which is greater than 0. That means it is the point of a minima. Okay. Right? So it is the point of minima. So from here, what you got to know that x equals to 2 is the point of a maxima. At x equals to 3, it is the point of a minima. X equals to 0, no conclusion. No conclusion. But although we know that x equals to 0 is a saddle point, but as of now, you cannot make any conclusion. So for x equals to 0, what do we do now, sir? If we want to mug up the things, if I don't want to treat it as an engineering subject, if I want to study as a JEE student, then what do I do? In the examination, if they ask you what is x equals to 0, you will be able to comment, sir, it is surely saddle point. But if you don't know how to draw this graph, then what you will do? X equals to 0, sir, no conclusion. Then what you will do is that you will triple differentiate. You find out that triple differentiation. When I triple differentiate, what I am getting? When you triple differentiate it, what you are getting? 12x square minus 13x, sorry, not 13x, 30x plus 12. 30x plus 12. 30x plus 12. Now in this triple differentiation, no, what you do? You put x equals to 0, because the x equals to 0 was not conclusive, no. So you do the triple differentiation. Triple differentiation you do. So when I did the triple differentiation and when I put x equals to 0 here, what answer I am getting? 0, 0, 12, which is greater than 0. So if it comes out to be greater than 0 or less than 0, basically what I did was y equals to fx was given, then I calculated f dash x, and then I put it equals to 0. I got a point which was x equals to x1, right? Then I put this x equals to x1 here. What I understood, what I will say, that at x equals to x1 I cannot make any conclusion. At x equals to x1 I cannot make no conclusion. Why is that so? Because when I put x equals to x1 here, it was coming out to be 0 only. Then what I did the triple differentiation. Then I put x equals to x1 here. Okay, either it could be positive or it could be negative. No matter whatever that you are getting, if you are getting it to be positive or you are getting it to be negative, then what will happen is that your x equals to x1 is the saddle point. Here if this value was negative, no, then also it was a saddle point only. If this value was negative, then also it was a saddle point. Let's just say the graph was just a negative sign here. Then what would have happened? Here the answer would come out to be minus 12. Still this x equals to 0 will be a saddle point only. So in the triple differentiation, if you have got it to be greater than 0 or less than 0, then it would come out to be a saddle point. Then you can say that it is saddle point. It is saddle point only. Now someone would ask, sir, what if even the triple differentiation comes out to be 0? What someone would ask us, sir, what if even that triple differentiation has come out to be 0? What I will do? Then you will differentiate 4 times. And in 4 times, sir, if I get it to be greater than 0, negative or less than 0, then you will give the answer as per this. Shall I take the example? Let's take the example. Otherwise, basically it is not a big concern for you. Okay, what double differentiation will give you, what triple differentiation will give you. This is just some method which gate examiner will not ask. Are you able to understand this point? Basically in the gate examination, if this question is coming, you will solve in this manner. No, job done. Why would you even move here? X equals to 0, saddle point, maxima, minima, that's it. Right? Sir, what is double differentiation test? What is double differentiation test? That I have already told. What is double differentiation test? That is clear here. That is clear here. Sir, what do you mean by triple differentiation test? 4 time differentiation test, 5 time differentiation test? That is not a matter of concern for you. No one cares about it because they are just method. No one will be asking you the method there, right? But let's take up some more example. It will be clear to you. Let's take up the example of fx equals to x to the power 5. Can you draw the graph? X to the power 5. Yes, sir, I can draw the graph. It will come out to be somewhat like this. For negative value, it will give you negative answer only. For positive value, it will give you positive answer only. So this kind of graph I will be getting. So x equals to 0 is neither maxima nor minima. It is a saddle point. X equals to 0 is actually a saddle point. If this question is coming, what is x equals to 0? You will be able to comment, sir, it is a saddle point only. Why is that so? You can see from the double differentiation as well. If I don't know how to draw the graph, what I will do? I will do the double differentiation. When I did the double differentiation, what answer I am getting? I am getting 5x to the power 4. Then, sir, where the roots will be there? Sir, roots will be there at x equals to 0. So, sir, for x greater than 0, this will be positive, sir. And for x less than 0, sir, this will be negative. No, it will be positive only. Why is that so? Because at x equals to 0, even power is there, it will not change the sign. What does that mean? What does that mean? If it is not changing the sign, what does that mean? It is a saddle point, right? It is a saddle point. But if you want to do some mathematics, then what you will do? You will do the double differentiation. So when I put it equals to 0, when I put f dash equals to 0, what I am getting? 5x to the power 4 equals to 0. So I am getting x as 0 only. This is my value of x1, right? When I find out f double dash x, what I am getting? 20x cube. If I put in f double dash x, if I put x equals to 0, what answer I am getting? 0 only I am getting, right? That means no conclusion. No conclusion. Now if I put f triple dash x, if I do, what answer I am getting? 60x to the power 2. So if I put x equals to 0 here, if I put x equals to 0 here, what answer I am getting? 60 into 0 square, this will be 0 only. Again no conclusion. Till the point where you are getting where you are getting the answer to be 0, no conclusion will be made. If I do the differentiation 4 times, if I do the differentiation 4 times, what I am getting? 120x. Again if I put x equals to 0 here, if I put x equals to 0 here, again it will come out to be 0. Again no conclusion. Now what will be 5 times differentiation? That is 120. Now if I put x equals to 0 here, what is the value I will be getting? Sir, there is no term of x, 120, which is greater than 0. Whether it comes out to be greater than 0 or less than 0. Now see that number of differentiation. 5 times differentiation you are doing, no? How many times differentiation I am doing? 5 times. 5 times. What is 5 times means? 5 times means odd time differentiation you are doing. So if your result is coming in odd time differentiation, then it will be a saddle point. Then it will be a saddle point. So if the result is coming in odd time of differentiation, then it will be a saddle point. Is that clear to you or not? If the result was coming in even time of differentiation, then it would have been a point of maxima or minima. Let's check up another example. This time I am taking the example of x to the power 4. Fx equals to x to the power 4. If someone asks me to draw if someone is asking me to draw the graph, what I will do? F dash x equals to 4x cube, right? Where is the point where it is becoming 0? Sir, it is becoming 0 at x equals to 0. It is becoming 0 at x equals to 0. For x greater than 0, it will be positive. For x less than 0, it will be negative, sir. So graph will decrease and then it will increase. So what will be the nature of the graph? So the graph will look somewhat like this. So sir, fx versus x will look somewhat like this. So the graph will look somewhat like this. Now I know that x equals to 0 is the point of minima. X equals to 0 is the point of minima. It is minima. But sir, I don't want to give the answer in this manner. In the examination, I just want to do the mathematics. Blindly, I want to do the mathematics. Then what I will do? Sir, I will do the double differentiation. What answer I am getting? Sir, I am getting the answer to be 12x square. 12x square. If I put x equals to 0, for x equals to 0, what is the value I am getting? 0 only. What does that mean? No conclusion. Then sir, I will do triple differentiation. Triple differentiation. 24x I am getting. If I put x equals to 0 here, again sir, if I put x equals to 0, answer is 0, no conclusion. Okay. Then sir, if I do 4 times differentiation, 24 I am getting. If I put x equals to 0, what I am getting? F dash 4 times differentiation at x equals to 0. If I put x equals to 0 here, what I am getting? There is no term of x, so I am getting it to be 24, which is greater than 0. So yes, conclusion could be made now. So now I will see what order of differentiation I have done. Even order of differentiation. Even order of differentiation. Here in the last time 5 times differentiation I was doing. So this was odd order of differentiation. Odd order of differentiation. So conclusion was made in odd order of differentiation, then it would be a saddle point. But if the conclusion is made in even order of differentiation, then it would be either maxima or minima. So if it is even order, then I will think about what? F double dash x I will think about. If it is a even order, then I will think about f double dash x. Now what f double dash x says? That if I am greater than 0, then it will be a point of a minima. If I was less than 0, then it would have been a point of a maxima. So if your conclusion is made in even order of differentiation, if conclusion is made in even order of differentiation, then it would be either maxima or minima. What I am saying is that if conclusion is made in a even order of differentiation, even order of differentiation, then so f even time differentiation you have done at x equals to x1, it is coming out to be greater than 0, then it will be the point of minima. Then it will be the point of minima. The f odd x equals to x1, if it is, sorry, not odd, I am talking about the even number of differentiation. No? If it is coming out to be less than 0, then it will be a point of maxima, right? And if conclusion is made in odd order of differentiation, if conclusion is made in odd order of differentiation, then odd order of differentiation, so at x equals to x1, whether it comes out with 0, either greater than 0 or less than 0, it will be a saddle point only. Saddle point only. Is that conclusion clear to you or not? I can write down a question. Okay. For y equals to fx, f dash x becomes 0 for x equals to 2, for x equals to minus 3, 4, 7, minus 2. Okay. Now f double dash 2, f double dash minus 3 is 7. Okay. F double dash 4 is minus 3. F double dash 7 is 0 equals to f triple dash 7, and f 4 times 7 is greater than 0. Understandable? Okay. And along with that, what I am writing down next is f double dash minus 2 is 0, f triple dash minus 2 is also 0, f 4 times minus 2 is also 0, but if f 5 times minus 2 is coming out to be minus 7, then comment that x equals to minus 3 will be what, x equals to 4 will be what, x equals to 7 will be what, and x equals to minus 2 will be what. So can I comment here that since it is coming out to be greater than 0, then x equals to minus 3 is a point of minima? Say yes or no. If double differentiation is coming out to be greater than 0, here we have seen if double differentiation comes out to be greater than 0, then it is the point of minima. Although these kind of questions they will not ask, but still, can we conclude? Here if it is coming less than 0, then it is maxima. Here where the conclusion is made, in 2 times no conclusion, 3 times no conclusion, 4 times conclusion has been made. 4 times means even. In even time conclusion has been made. That means I will give the answer as per the double differentiation only. Still if it is greater than 0, or here I could have written some value. Okay, let's write down this value as 3. So since it is greater than 0, then it will be a point of x equals to 7 will be a point of minima. And here what do you see? The conclusion is made in odd time of differentiation. Since it is odd time of differentiation, no matter whether it is greater than 0 or less than 0, it will be known as what? It will be known as saddle point. That means x equals to minus 2 will be a saddle point. Is that clear to you or not? Is all 4 points clear to you or not? Although from this particular slide, whatever the discussion that we have done from here onwards, here I just wanted to prove that this will be saddle point, maxima, minima, but yeah, conclusion is made on this particular slide. So when you revise, how will you revise? You will revise this slide, you will understand the meaning, and then directly you will go to the last slide and you will understand the meaning of this slide. that if the conclusion is being made in the even differentiation, then you treat it as a double differentiation only. If the conclusion is made in odd differentiation, no matter whether it is greater than 0 or less than 0, it will be a saddle point. Sir, what will be the point of inflection? Point of inflection can be found out only from the double differentiation. For point of inflection, you cannot comment by using these derivative test. For point of inflection, what you will do? You will do the double differentiation. You will check whether the sign is being changed or not. If the sign is being changed, what does that mean? That means yes sir, it is a point of inflection, otherwise it is not a point of inflection. So double differentiation we need to do. So is all the concept clear to you or not? Are you mugging up a single thing? No, not a single thing we are remembering. Only in the end here I am asking you to remember something, otherwise complete concept is clear to us. Everything is crystal clear, to the point everything is crystal clear. Every single point we have seen, how the slope is increasing, decreasing, what is the meaning of increasing slope, decreasing slope, what is the meaning of increasing graph, decreasing graph. So everything is crystal clear, not a single point I am asking you to remember. Is that clear to you? Is that appreciable for you? If it is appreciable, you need to comment down. Okay sir, that is this kind of mathematics we are learning, and we are grateful, or not to be grateful, that we feel good about it. And complete mathematics I am going to cover. If it is a promise, then it is a promise. Complete mathematics will be covered in the best possible manner. You would have never seen this kind of mathematics on any channel you see. Okay, you take the channel of 1 million subscriber, 2 million subscriber, 2 lakh subscriber, 3 lakh subscriber. On this channel of 30,000 subscriber, you will get the best possible mathematics that you would ever see in your life. That I am guaranteeing. You can call it arrogance, you can call it whatever, or you can call it overconfidence, but that's the level of confidence I have on my content. Understandable? All good? All fine? So yeah, you can share it with your friends, to your good friends. Why will you share it to all your friends? Because you would know that they will increase the competition. So to at least your good friends, you can share this content. Okay. Thank you very much. Happy learning. In the next lecture, like almost the concept is completed. We will see the questions. We need to build up the problem solving skills as well, no? So we will see the question, how to solve the questions of a GATE examination. Okay then? Yeah. Thank you very much. Happy learning. Let's meet in the next lecture.